This 5 hours long project style tutorial will teach you how to build an agentic AI data agent which will be having sub agents such as SQL Analyst, ETL Analyst, etc. that can work together without losing the state. Here you will master all of the in-demand skills in the AI world such as React architecture, stateful orchestration, Pydantic models, AI as a judge, sub agents, Langchain and LangGraph, databases, context engineering, and much more. This project is built for beginners. That means if you just have basic Python understanding, you can easily follow along and learn all of the concepts. And the best thing, all of the things are explained using amazing doodles and visualizations so that you can easily grasp everything. And yes, all of the notes, code files, resources, everything is provided for free with this video. That means if you have decided to upskill yourself in the world of agentic AI, then this project video is the best solution available for you, because here you will learn actually everything by doing and building it. And obviously if you just want to support this guy, simply hit the subscribe button and hype button, and let's get started with this amazing agentic AI project tutorial. So what's up fam, happy Sunday. On this Sunday we are going to create an amazing agentic AI solution, aka data agent. And yes, I know you were just waiting for this since so long, but finally it is here. So without wasting any time, let's try to first of all understand what we are trying to build. So let's say you have the users to serve, okay? You have business stakeholders, managers, and blah blah blah, all those so-called technical people who do not even know how to write code, okay, but they are just making business decisions for the company and they are actually building the organization. We all know that. So now they were keep on coming with the recurrent problems, recurrent queries that were really annoying for any data professional, especially for like queries like, let's say a user is saying that, hey, could you please fetch this data for me, could you please run this SQL query for me, and blah blah blah, and just send the CSV file to me. These are the roles, obviously, like these are the things that are obviously aligned more on the junior role side, so obviously they would understand this better. But let's say you are now allocated to build a solution to automate this thing, bro, because obviously AI is here. So what we gonna do, we gonna automate this entire thing that a junior data professional does. What are the two most important things that a junior data professional does? Python and SQL. Let's talk about SQL first of all, because I know SQL is very important. So what I am gonna do, I will take the user query. Let's say user says, I want to find sales for this month, okay? Let's say anything. You can literally expect anything from the business stakeholder, and that too in the layman language, because obviously you cannot even expect a good prompt from a business stakeholder, obviously. So let's say this is the problem that is, or this is the query that we need to solve. Now our agentic AI solution should be smart enough to automatically divert or basically deroute this query according to the nature of the query. I know that this type of problem can be solved using my SQL database, and because we are just talking about the Ola database, or you can say Ola ride sharing database, we will be sending this particular prompt to our what? To our sub agent, because this data agent is the parent agent, or you can say the main agent. Within this particular agent, it has a team of developers. Really? Yes, let me show you. So this is the SQL analyst, or basically the sub agent, or basically you can say the developer within the team, and you can just treat this data agent as your team lead, and team lead assigns the work obviously, and this will send this information to the SQL analyst. And now do not start biting your nails. Hey, what is this thing? Hold on. This is called stateful agentic AI solution that you need to build. Okay. What are we doing this thing? Like, what are we doing in this thing? Nothing fancy. Just think about it. How you or a normal human being will try to create this type of agent. We need to perform some steps in the specific order. Just to give you a hint, because obviously we need to just discuss this thing in detail when we will be just building the SQL analyst, right? But here, just to give you a glimpse, it will simply perform some steps in the stateful manner. That means it needs to take care of the result of the previous step and needs to perform the rest of the things like using that particular state, right? And here what it will do, it will simply take your query, let's say whatever this person has said, it will curate the question, because obviously business stakeholders cannot even write the better prompt. Then we will simply add the context from the Ola database, whatever the organization database we have. Then we will just send this information to LLM, then it will generate the query. And then we also gonna make sure that the query that is generated is safe or not, because we cannot just run anything on the fly. So it will simply perform that thing as well. If the query will be safe to run, then it will simply run the you can say query, and then it will represent the result back to our agent. And this agent will you can say provide the result back to this data agent, which is, you can say, the senior agent, or you can say team lead. Make sense? Very good. Here we will be just performing a very cool thing as well, not like very cool. We will be just taking care of the different LLMs, because there are so many large language models available out there. So you need to make sure, like you need to make sure that you are using a high-end LLM for, like, you can say tasks which require like more amount of knowledge, or you can say when you are just generating the code, and low end LLMs when you are not performing anything computational specific thing, like not generating the code, right? So we will be performing that thing in the SQL Analyst. This is my first data or sub data agent. After that, let's say this time this user says, I want to extract the data from API, and I want to transform it, right? The person can ask this thing, right? So for that particular task, we have the second sub data agent, which is your React agent. If you do not know about React agent, do not worry, we're gonna just talk about all of these things. So this is you can say agentic agent, or you can say React agent, which performs a thing in a loop. So here what we will do, what we'll be just doing, we will be creating a lot of tools which are Python specific tasks, where this particular agent will make sure that I have all of the tools and I can literally perform anything. I can just transform the data, I can extract the data, I can literally, you can say, save the data, load the data, and whatever, using Python. Wow. And if the work is done, then it will simply go back to this data agent, and data agent will respond that, hey, your work is done. Make sense? Very good. So this is, you can say, the architecture that we are going to build in this particular project. So first thing is, for sure, that you are going to learn a lot of things, literally a lot of things within this project. And that is the agenda of this particular project video, that you will learn almost not everything, but most of the things that we just perform in the agentic AI. Make sense? Like, you can say, all of the essentials that you should know, you have to know in 2026, or obviously now in 2027 as well, obviously. So this is the architecture that we are just going to build in this particular video. If you like the architecture, if you are excited, simply show your excitement in the comment section so that you can communicate with other learners as well. Okay. And just a quick information, in this particular entire video, we'll be using open source databases, open source frameworks, open source programming, which is Python. So it is like very easy to follow along. You do not even need any kind of cloud account or anything, because everything is open sourced, obviously except LLMs, but that is also good. Make sense? Okay, so now let's get started with our some fundamentals that you should have. So now I'll be just talking about some of the very fundamentals of the agents. I'll be just talking about React agent and stateful agent. These are the two very popular, you can say, agentic architectures that we follow while building any agentic AI solution. Okay, so let's try to just have a look on those concepts as well, and then obviously we're going to just start building our data agent. Okay, let's do it. So now let's talk about the fundamentals, okay, especially in the world of agentic AI. What is agentic AI? Okay, if I just ask you this question, what is agentic AI? Now I know you have remembered amazing cool definitions from Google. Okay, good for you, but let me just tell you, agentic AI is nothing but, let's say you have one data agent, okay, and you have, let's say, one more data agent, you have one more data agent, when you have one more data agent. So when you are communicating between multiple data agents, okay, this becomes your agentic AI solution. Why? Because when multiple data agents can talk to each other, they can literally serve the entire domain in itself. So let's say I'm just creating data agent where I have like, let's say 2 sub agents. So that is called like agentic AI solution. Why? Because it can autonomously divide the work between the agents, and agent can actually perform the entire thing in itself. So agentic AI is nothing but just, you can say, the combination, the network of multiple AI agents. And till I would say early 2025, AI agents were in demand. But right from the start of 2025, or I would say mid of 2025, agentic AI started gaining popularity because everyone understood that building AI agents alone is not fruitful. We need to build the entire graph where multiple AI agents can talk to each other, because that serves the entire purpose. Otherwise, what will happen? Obviously, AI agents can also do the work, but what will happen? Then overhead will become more. So let's say data governance, or let's say AI governance, AI ops will become, you can say, bottleneck. You cannot govern each and every single agent, but it is easier to govern the entire solution. Like, it is not very easy, but it is better to maintain, let's say, 10 different agents rather than just maintaining the one exact like entire agentic AI solution. And second advantage is, same agentic AI solution can solve different varieties of people as well. So in our case, we can solve SQL problems as well, Python problems as well, so on and so on. This is your agentic AI in a nutshell. Cool, very good. So now let's talk about the AI agent, because we have understood that agentic AI is nothing but just the combination, network, communication of multiple AI agents. Now, what is AI agent? What is this cute little guy? This AI agent is nothing but just your, you can say, program. One program which can perform 2 different things. Okay. One is, let's say, stateful orchestration, or not orchestration, you can say stateful execution. Okay, which is like one type of AI agent which I personally love a lot. Second thing is React architecture, which is one of the most popular framework, or let's say I would say structure, since the beginning of this AI era. React execution. So what is the difference between two? Basically, whenever you just want to perform any execution in the exact order, you do not want AI to take any decision between those things. AI can take the decisions, but not, you can say, the major decisions, and not at every step. Okay, it will have a kind of execution order. If I just show you the example, in our SQL case, we will be just building this particular thing where we have the entire sequence. We have some, you can say, autonomous behavior here where LLM takes the decisions, but we are still running a lot of steps. Do you know what? If you have built these solutions, you will understand that stateful orchestration, you can say stateful execution of AI agents, is the best way to build the agents. Okay, but that doesn't mean that this is the only structure we follow. There are like multiple structures. This is one of the best structures that you can just rely on. Okay, cool. So this is about stateful execution. Then comes your second one, which is your React execution. React execution is nothing but reasoning plus acting. Okay, as the name suggests, it will not just run the steps, it will run a loop. It's called React loop. And what is the loop? Just 2 components: React reasoning, acting, reasoning, acting, reasoning, acting. That's it. For example, in our case, let me just give you a fresh example. Why to take the same example? So let's say you have one LLM, because LLM is the brain that we just use. So this is the LLM. Okay, now let's say this LLM can serve some users, right? But only that thing which is available to this LLM. Obviously, the data it is trained on and some capabilities that it has, but not everything. Obviously, because this LLM cannot run your Python code. It does not have any kind of runtime. It does not have any kind of sandbox, nothing, right? And obviously, it cannot even generate the Python code if you do not provide the right context. So it is capable of doing the things, but it cannot do anything. So here what you do, you simply attach the tools. So let's say this is your toolkit. Okay, you can just imagine toolkit as like a lot of tools. Okay, lot of tools. So here what you do, you simply go to this tools. Okay, let's say this is your toolkit. Cool. What is this? What is this? What is this?
toolkit. Okay. Now, if I just want to use any tool, I will simply go to this toolkit. Let's say I just want to search anything on Google. I will simply create a tool for the web search, and I can simply go to this toolkit and I can just make the tool call. Simple. Now what will happen? This tool will generate the response, and this response will go back to this particular agent. Okay. Now LLM will say the response that is generated by the toolkit is enough, or do I need more context? If I need more context, it will again go to this toolkit, search for the right tools, and then make the tool call, get the response, then check, reason it, do I have everything? If not, again act. So it is called react loop. Make sense? This is your react loop. It will keep on doing this thing until LLM feels that it has literally everything that it needs. Oh, this is your React agent. And this is the agent that we're gonna just build in case of building this particular Python, or basically ETL data analyst or ETL analyst that we are just going to build. Okay, so there are like two subagents, SQL analyst and ETL analyst. Cool, very good. So that is it. And we will be just talking about like everything within the dedicated sections. When we'll be just building SQL Analyst, we will talk everything in detail about stateful execution, obviously, and same with the React execution as well. And I would say these fundamentals are more than enough, because when you will be just building everything, you will understand everything along the way. Okay, so now let's start building our very first agent, which is SQL Analyst agent, and just write a comment that I am building SQL Analyst agent right now. Okay, so simply drop a comment and let's start building it. So now let's first of all try to talk about this important sub agent, which is your SQL Analyst agent. Because the thing is, whenever we are trying to build any data agent, we obviously need to focus more on SQL, because every data professional work with SQL most of the time. And obviously, if there's a kind of data or junior data agent, SQL is like the bread and butter. But the thing is, in order to create the SQL agent, we need to understand the entire architecture, how one just generates the SQL query. Some people will say, bro, it is very easy. Simply provide the prompt and LLM will generate the query and done. What? It is not the way that you just build the agents in production, or let's say in the real world. It is very easy to show these kinds of agents in the prototypes, because you just need to provide prompt, you will get the SQL query in return. Wow, clapping. But in order to generate the queries which will be used by the stakeholders, need to be first of all assessed, and it should obviously pass some checks, because we do not afford any kind of safety issues with our queries and so many other things. And obviously context is the major thing. Okay, and in this particular SQL agent, we have like multiple options, as we have seen like what are the options available for us in order to build any agent. It can be autonomous, it can be tool calling, it can be workflow, it can be stateful agent as well. And we will be creating a stateful agent, because whenever we want to create a SQL agent, stateful agent is one of the most successful agents that I have personally seen. But yes, people can build tool calling SQL agent as well. But according to me, SQL agent should be stateful. It should maintain the state in every particular node, and that way it can actually generate the queries better. That is my personal take. Okay, and obviously we're gonna just build so many sub agents. So this in this particular sub agent, we'll be just building stateful agent, which is one of the most complex agents as well. But don't worry, I'm here. I will just make it very, very simple. Do not worry at all. So what this AI agent will do? This AI agent will literally run the entire graph in a sequence, maintaining the state, right? So what can be the steps? Let's say there is a business stakeholder. Let's bring one user, okay, or let's say 3 users. So we have these users, and now I want these stakeholders to use my agent, right, to generate the redundant tasks like SQL, because every time they complain, hey, could you please run this SQL query? I want to find this data. I want to do this. I want to do that. I don't know what they do with that data, because if you will look at the balance sheet of the company, you will see like they're doing literally amazing work with that data, but they need SQL query. So now how I can just generate the query, or let's say how my agent can generate the query using that particular garbage prompt. Why did I say garbage prompt? You cannot expect from a user to write high-end, most beautiful prompts in the world. No, they will literally write garbage. But Ansh, Lamba, there's a rule like garbage in, garbage out. Yes, to some extent, because that is why those business stakeholders who are not very technical, they are also learning about prompts. But you can literally cannot like totally depend on them. You still need to add some you can say purification of that prompt by yourself. So the very first thing, whatever this business person is saying, my agent should first of all curate the query. First of all, curate the query. Make sense? Or enrich the query. Same thing. Cool. This is the first step. Right. First step means first node, because I am creating a stateful agent. So I'll be creating multiple nodes. Remember this step because this is very important. So the very first step will be curate the query. That means curate the user response, like what this person is saying. So query will be not be a very handy word. Let's say curate prompt, or let's say curate question. Simple, perfect. Curate question. So this will curate the question first of all. Very good. Now we have the well-written prompt to some extent, obviously, right? Now the most important thing, these users want to run query on top of a database, obviously, right? Or any kind of data warehouse. For our example, we are taking the database, but you can just literally replace it with database, data warehouse, lakehouse, everything. Okay, so let's take an example. We are using, let's say, Postgres database. So this is our Postgres database. Perfect. And we at the end of the day want to run the queries on this Postgres database. Perfect. Remember this thing as well, because we're gonna use this context. Now my question is ready. So the output of this question, or basically state of this particular node, will be updated in my parent state. We'll talk about state in detail, do not worry. So that means my question is enriched, my question is curated now. Now I have like well-written question. Now I need to involve LLM, because I need to send this question to LLM. That's what we want, right? Okay. Let's bring LLM. Let's say I have this LLM in the picture. This is my LLM node. So let's say LLM node, because node word is very important. So now just tell me one thing. Can I literally send this question to LLM node? A lot of people will say yes. Really? Okay. Okay. Let me just show you practically. So let me just open one browser. And let me just open one private window. Let's go to ChatGPT. And if I say ChatGPT, I want to find total number of orders we got last month. Make sense? This is the prompt that person has sent. Literally this prompt, or let's say this is the prompt that we got after curating it. Now, if I hit enter, I will say generate the SQL query and blah blah blah. Query for this. So now this will assume automatically something. Select count asterisk from as total orders from orders where created. You will say, wow, our agent is ready. See, we can just send this question to our LLM and LLM will generate the query. We have built the agent. Yes, we are AI proof. Bro, just tell me one thing. Do you have orders table? No. Do you have this column created at? No. Do you have current date or anything? Maybe. I don't know. So that means this query is literally garbage. Why? Because this query will not work on one database, or this might work on one database. Because this LLM does not have any kind of context. That is why context engineering is again now increasing very rapidly, because those days are gone, like where people were literally sending the prompt, getting the response back. Now it's time to build the actual solution. So context engineering is very important. In SQL, context engineering is very easy, because just tell me one thing. If I just provide this context like this, let's say I want to refresh this thing. If I say I want to find total number of orders we got last month, and if I just let's say generate SQL query, and if I say generate this query, but I also provide some context. My table name is this, okay, my schema name is this, blah blah blah, and my column names are this, and blah blah blah, so many things, and column data type as well, obviously, because schema. Then I would also need to provide some sample data so that it can just judge like how to create the query, how to just perform some, you can say, text rendering and all, right? So that means I need to provide this context. Now you tell me, can this business person provide this context? Can. Yes, but will he or she provide it? Obviously no. Obviously no. They cannot just provide the context. Why? Not because they are lazy, because this database is so huge. There can be, let's say, 20 tables. 20 tables are like very less, but let's assume 20 tables. And in each table you have 10 columns. So in total 200 columns, 20 table names, one schema name, and then sample data of those tables need to be provided to LLM with every response if you want to get the query out of it. This is one of the most important node that we need to create. It's called context. Okay, so I'll say add context. How we gonna just add this context? We will just create obviously this node. This is like one of the most important context. Then once this query has the context, then it will go to LLM. Obviously, really? No. Then we gonna simply add one more node to check if it is safe or not. Oh really? Yes. Or we can just simply because we simply gonna create the query, then yeah, perfect. This can just go to LLM. Then this LLM will just read everything out of it, right? Because this context will be given from here. This will be a kind of you can say node we're gonna create. Perfect. So this is our context. Once the LLM generates the SQL query, let's say our SQL query is generated by the LLM. Obviously it can generate the query. Now this will not be directly executed. Why? Obviously it is risky. We do not know like what is written inside the query. Then we gonna create one node which will check if the query is safe or not. Because there can be so many, you can say, things that we can just do inside the query. So we will simply say safe or not, right? If it is safe, then it will run against this database. Oh yes. Then it will run this against this database. Make sense? Then what will happen? We will get the response back, right? We'll get the response back. Then we gonna run the query. Let's say this particular query, and this will run on this particular database. Make sense? So let's try to attach it from here. It makes more sense. Let's say run. Simple. Now once this query is completed, obviously we will get the data back, we will get the results back. Now we will send this particular result to LLM for one more time. Why? Just to make it in a representational manner, because you cannot just directly represent the data. Like you can, but it's always a good practice that you can simply provide the final answer to LLM, that simply say, hey, perform this thing and just make it better, and that's it. Make sense? Very good. So then once this LLM has the final response, then we gonna present it to the users. This is the entire graph that we need to build. Let's say represent. I hope it makes sense. And this will go back to these users like this. So this is the agent. Obviously this agent will just send the data back. So this will be, let's say, flow back. Simple. And you have understood the entire flow, how it will do it. I hope it makes sense. Okay. Or you can just make it like this as well, because this will start it and this will get the data back from here. I hope it is clear. Now, just tell me one thing. How many times we are using LLMs? How many times? You will say 2 times, not 2 times, 3 times, because this will also a kind of LLM node. Why? Because we're going to just create the query, and we cannot just create the query on by ourselves. We have to just include this LLM within this node. Yeah. So now one important question, like you can even ask from yourself while building this thing. We have so many LLMs available, and every LLM is obviously not similar or same in terms of price. Some LLMs are very expensive. For example, if we just go with OpenAI Soul, which is like recently added, Fable 5 by Claude, and I personally do not like Gemini models for coding and all, but yeah, Claude and OpenAI are good. So let's say you just want to perform so many things with LLMs, literally 3 things, 1, 2, 3. Should we use the same model? Obviously no. So how we can just decide the model? So here in this graph, we also gonna add the functionality when we need to switch to a high-end LLM, when we need to switch to a low-end LLM and the medium LLM. Because just tell me, do we need a very high-end LLM here just to curate the question? Because it just needs to take your broken English prompt and make it curated. Simple. So we will simply use low end LLM here. Makes sense just to save cost, but we need to use one of the best coding models, high-end model. Why? Because we need to generate the query. It cannot be syntactically wrong because it can just literally break the query. And then once everything is fine, then again we can just simply use less end model. Why? Because, or let's say low end model. Why? Because again it will simply take the English and it will simply, let's say, explain it better, or might summarize it, might make it more better form of that particular question. So that is not a big deal. Again, this way we can just actually save the cost. This is the entire SQL Analyst agent, stateful agent that we are going to build. This is one of the best, you can say, way to build the SQL Analyst agent. Why? Because if you just go with the tool calling agents, you have to provide the context in every single tool, and I have seen sometimes it can create a mess. And that way you will also not have the option to switch between the high end and low end LLMs. Again, cost is important. In that scenario, you have to use high end LLM. There is no other choice, obviously. So this is the architecture. I hope you have understood this thing, because once you understand the architecture, only then you can build it. We will not be just discussing this architecture again and again. It is discussed now. Perfect. Now it's time to build it. So now in order to get started, I would need some things to get installed on my system. First of all, I will need to download Python. If you do not have Python, very good, because this is the thing that you need to have in your system and you do not have. So simply go to your browser of favorite choice, Python, let's say download, and click on this very first link, and then you can simply click on looking for Python for Windows. If you are on Windows, if you are on Mac, click on Mac OS, and if you are using your phone to code, simply click on Android. Maybe you are using any tab or something, so you can simply click on Android. Click on Windows if you are on Windows like me, and you can literally pick any Python version. These are the stable versions that we have. Currently I have 3.11 and 3.12 installed. I think 3.13 as well, but you can literally download anything. Make sure you have the Python installed. Simple, very good. After Python got installed, you need to install one IDE. I am using VS Code, so you can also download VS Code if you want to. So click on this link, and Windows, Linux and Mac. Download it on your machine, and it has, I think, all the options. It has like ARM64 as well. So if you are using ARM based architecture, you can simply go with ARM64 as well, because I know some Microsoft books are using ARM based architectures instead of your traditional x86, x64. So yeah, simply go with this one if you want to. Simple, very good. So this is all about downloading VS Code and your Python. Very good. So now let me just open my VS Code. So this is my VS Code, and it might look a little bit different than yours because I have just downloaded some themes, but that is not a big deal. You can also download it and you can just make it feasible for you. One thing you need to make sure, you need to open VS Code in an empty folder. How you can just do that? Simply go to File, click on Open Folder, and select any empty folder of your choice. Make sure that you have permissions to use that folder. Do not open it in the OneDrive and all, because it might create some mess. Simply open one folder on your system directly in C or D drive, wherever, and make sure the folder is empty. As you can see, in my case, it is totally empty, and the folder name is Data Agent because I have picked that name. You can just pick any name. Cool, very good. So I think our setup is done. Now we simply need to open the terminal. Click on these three dots and click on Terminal, click on New Terminal. You can also open this terminal by clicking on Control, Shift and Backtick, and either way, we just need to open the terminal. So my terminal is here. Currently, we do not have anything here. So first of all, we need to check our Python is installed or not. Simply say Python -- version. Currently, it is saying 3.11.9 because this is my default Python version that I have set. In your case, if you have already Python installed, make sure you are using 3.11 onwards, because 3.10 as well, but not below that, because I have seen the modern Python frameworks do not work well. And to be honest, if you just want to follow everything as same, simply install 3.11.9 and that's it. You can just find that version from the list that I have just showed you. Simple, cool. Here we need to install one thing. It's called pip install UV. UV is a modern and fast Python package manager. We do not use pip now. in most of the projects, or I can say in most of the new projects. So we use UV. So you can also install UV like this. In my case, it is already installed. In your case, it will be installed right away. Cool. Very good. You can also check UV hyphen version, and my UV version is 0.9.11. Cool. Now we need to create a virtual environment in Python, because whenever we create any project in Python, we simply create the virtual environment because we do not use a global Python environment. So in order to create that, simply say UV init first of all. It will create some that boilerplate files and all. So I can see Python version, main, toml file, everything, and one .git folder as well. In some cases, you might not see this .git folder if you do not have Git installed on your system. But because we are not covering any Git and all here, so if it is not installed, if you do not see this folder, it is fine. Cool. And in some cases, even you have Git installed, you might not see this folder because you might have hide it from your settings. Okay, so that is fine. In either case, everything is fine. Now you just need to run one command, UV sync. This will create the virtual environment for you by syncing all of the dependencies that you might have created. Plus, if you just changed your Python environment, it will just perform everything automatically. But we didn't even change anything. We didn't even add anything. So it will simply create the virtual environment and that's it. It will not do anything, which is a good thing. Now we need to add some special things. First of all, we need to add one .env file. Perfect. Now let me just go back to my lovely architecture. Now, because we are using LLMs here, and obviously LLMs are not free. Okay, now they are not free. In the earlier days, they were like free for like, I would say for the initial months when LLMs was like new thing in I think 2023. OpenAI was providing some free credits, but now not every LLM is free. And I would say no closed source LLM is free. So here we need to simply create one API with LLM. Now the question arises is, Ansh, should I use OpenAI, right? Should I use Claude? Simple. Like you have like multiple options, right? Maybe Gemini if you have Gemini API as well. So you can literally go with any API. Okay. If you have Claude API, you can go with Claude API, because this entire project, basically the agent that we are building, is irrespective of LLM. Why? Because we gonna use the frameworks like Langchain and LangGraph. They are actually made for these purposes, where LLMs do not actually create any problem, because frameworks are like wrappers built on top of these LLMs. So you do not need to worry about the behavior change. Zero behavior change will be there, zero. So we just need to use the power of LLM in our framework and that's it. Cool. So if you have Claude API available, you can simply create one Claude API. If you have OpenAI API, you can create OpenAI API as well. Either way, it will work. But you need to have one OpenAI API or Claude API or Gemini API. Cool. Very good. In this demo, just to show you, I can show you how you can just create one OpenAI API. But if you have Claude, you can simply go with Claude as well. Cool, because both are good, but OpenAI obviously provides nowadays some cheaper options, obviously 1/3 or I would say 1/4 of the cost as compared to Claude. So why to spend more money when we have like cheaper models and with great intellect? So simply go with OpenAI. So how you can just create one, go to your browser and search OpenAI API console, and this is OpenAI platform, and you can just click on this thing. Yeah, so first of all, you will need to log in. Okay, and let me just open my account so that I can just show you what do I have. So I have opened a new tab, and here simply go to this website openai.com/API/ just to land on this page, because whenever you just use any other browser, you might not see this web page. So here you need to click on login. Here you have three options: ChatGPT, API platform, and Codex. Obviously you do not need to open ChatGPT and obviously not Codex, because we need to just simply go to API platform. Simply click on this API platform. And then here, this is the page that you just need to make sure, because I think the previous page was also this one, but I just showed you the previous page so that you have the clear understanding as well, right? So this is my home page for OpenAI API. Currently, you just need to do one thing, which is your API key. Simply click on this API keys and create one new API key. Cool. So let me just create one new API key for this project. So I'll simply say data agent. Wow, data agent. Okay, and project is default project, and create secret key. And here I can just copy this thing, because once it is copied, it will not show you to you this thing again. Okay, simply say copy and done. So API key is done. Now you will say, okay, let's use it. wait. It's not like, okay, it is created, now let's use it. So now you need to simply go to home, and here you might see this UI. Okay, they just keep on changing this thing. So you can even go to settings, organization. So you will see one option to add some balance. So currently I have some bucks available in my account. You also need to have some credits available. I think at least it asks for, I think, $5. I don't know. You can simply check it, how, like, what is the minimum balance. You can simply add minimum balance, and that will be like more than enough, obviously, to build this agent. Plus so many agents. If you just want to learn more and more things, you can just keep using that thing. And obviously the expiry of this will be 1 year, so you can just use this balance for 1 year. So totally up to you. This is OpenAI. Similarly, you can also create the Claude API as well. Similar steps. Simply search Claude API console, and that's it. Okay, everything is same. Now we have the API key, we have some balance, that means we can use it. Now I can just show you some models that they have just launched. So there are the 3 models. 5.6 Soul is the high-end model. 5.6 Terra, which is actually very good, that we can just integrate within our solutions for agents. And Luna is really good, but not that much good for agentic tasks, but it is good for, let's say, summarization and all. So I just told you these 3 things in the architecture, right? Same thing. So obviously we have like a long list of models that we can just compare. Even if you just go to your, let's say, let me just open that page for you. So if you just go here, let's say, search OpenAI models. So they just keep on launching new models every single month. There's a race going on to build models. So this is our model that we have: Sol, Terra and Luna. 5.6 is the most latest GPT models that we have. Simple. Now you can even compare the price. Go and click on pricing, and here I have the cost. So I have $5 for input, okay, for Sol, which is the highest, the best model so far. And then we have Terra for $2 and Luna for $0.2, because obviously this is like for low end tasks, but not like it cannot perform those high end things. It can, but obviously not for coding and all. Simple. So now you will say it will ask us $5 for one request. No, price per 1 million tokens. So whenever you provide any kind of prompt, that prompt is consist of tokens. These are like very fundamentals that every data person should know. And I already have created like one AI fundamentals masterclass where I have just talked about these jargons and concepts. But don't worry, you do not need to have that knowledge, like complete knowledge. It's fine even if you do not know. So let me just tell you, tokens are nothing but just a combination. Let's say you just write a word. Let's say you say write a SQL query. Okay, so just for your understanding, you can say this is a token, this is a token, this is a token, this is a token. But in reality, each word is actually consists of tokens. So that means there might be 2 tokens associated with SQL. Maybe S will be a different token, QL will be a different token. It depends upon the vocabulary of the LLM creators. OpenAI will have a different vocabulary, Anthropic will have a different vocabulary, Gemini will have a different vocabulary, and so on. And you do not need to worry about this thing. Okay, so just make sure, like, tokens are nothing but just basically the length of your prompt, and that's it. It is like directly proportional to the length of prompt. Okay, so when you have 1 million tokens in your prompt, then you will be charged $5. I hope it makes sense. Very good. So we can just use this Luna, Terra or Sol. Okay, these 3 are like very good models, by the way. So yeah, we're gonna just use maybe Luna and Terra. We do not need to touch Sol because Terra is like good enough to just generate our code, and it is like really good. Sol is good when we need to build the terminal level agents, like agentic agents. Okay, what is this thing? Hold on. So much stuff we need to cover. Okay, so perfect. We have the API available. We have everything available. So now we can literally go to our VS Code, and in the .env file, if you are using OpenAI API, you need to create this environment variable OpenAI API key. Okay, this will be my key for this project. Obviously, I will just delete it after this. So this will be my key. Why do we create this particular key? Because we do not need to hard code any kind of sensitive information like API key in our code. We always go with .env file. I hope it makes sense. Very good. So this is all about that we need to just have before actually getting started. So first thing first, we need to have one folder for our project, Python project. So let's create one project folder called Utils. In the Utils folder, we will write our core logic, basically the classes, functions, literally everything that we just need to create. Helper functions. Then we can create one folder called agents. In the agents folder, we will just write all of the core logic for agent. Basically, all of the sub agents will live inside this agents folder. I hope it makes sense. So Utils is here, agents is here. Then we can also create one folder, let's say data. Let's say if we might use it, not sure for now. Then I think we do not need anything else. Then we can have one main file which will run everything from that particular file. So I can simply use this main.py. By default, they just write this demo code, but you do not need it. So simply empty it. So we have main.py, then we have utils, data, agents, and everything. I hope this folder structure is clear, and obviously we can just update it as we follow along. Make sense? Cool. So now we would need to install some packages in our virtual environment for this agent. As I just mentioned that we'll be just using Langchain, LangGraph, which are my favorite frameworks to build the agents and agentic AI solutions. There are some other alternatives like Creo AI and all, blah, blah, blah. But I simply love Langchain, LangGraph because we have amazing Pythonic way to create the agents. Plus, great community support. They just keep on adding amazing connectors and amazing integration with applications, amazing stuff. So first of all, just for those who are using Claude key, so you would need to create this environment variable. Let me just show you. So this is my, so let's say Langchain Claude, because I am not sure whether they need to use Claude API key or Anthropic API key, because recently they just changed this thing. Chat Anthropic integration. So let me just see the key name so that everyone is on the same page. So let's see. Yeah. So if you are using Claude, so do not like Claude API key, because recently I remember they just changed it. Simply use Anthropic API key. Okay. Same way we just wrote OpenAI API key. So now you need to just write Anthropic API key. I hope it makes sense. Simple. That is it. That is it. You do not need to worry about anything else. Okay. Cool. And do not worry about these chat Anthropic, because we are not going to worry about this thing. Okay. So simply minimize it. Simply make sure that you have this .env and you have the OpenAI API key or Anthropic API key. Let me just write it for you. Anthropic API key. I can just write my API key for Anthropic as well, just to show you that we can just use, or let's ignore it. Anthropic API key. So this is our environment variable. Cool. Now I would need to install Langchain. So I can simply say uv add Langchain, and it will just add Langchain module. And I would need to add so many others as well. So uv add LangGraph. Perfect. That is already added. And I think uv add Langchain and then OpenAI. Cool. Langchain OpenAI. And if you are using Anthropic, simply add uv add Langchain and Anthropic. Cool. Yeah, that is good. So we have some modules available. If you just go to toml file, you will see these modules in the dependencies. So we have 4 modules. So this way you can actually sync all of these things. Okay. And obviously I will just provide everything in my repo as well. So you can even use that toml file. And when you will be running UV sync, it will automatically download those packages. And I can even create the requirements.txt file just for you, but do not need to worry. Cool. So we have Langchain as well. So now we need to simply go to this agents. Okay. And in this agent, we will simply say SQL Analyst.py. Cool. So now we just need to create the SQL Analyst agent, and what should be our, you can say, tasks. What should be our nodes? What should be our way to create this? Because this is the architecture and we need to create so many nodes, right? So nodes are what? In, let's say, Langchain or LangGraph, like both are same thing. Built one on the other. So when we just want to create, let's say, anything in our Langchain or LangGraph, right, we need to have, first thing is nodes. This node, right? This node. But even before working with this node, we need to define the state. Now what is the state? State is nothing but just your, let's say, the metadata that you just need to carry along within your agent. I hope it makes sense. So how to define the state? State can be defined using two things. The one is Pydantic models. Let me just zoom it. Pydantic models. Second one is your normal type detect. These are the two ways we create, or basically we provide the schema, or basically the metadata or state. Pydantic is very good when you want to make sure that schema should follow the rules strictly, and if it does not follow the rules, it should break the entire agentic flow. But type dict is not very strict. Even if it does not follow the data types, it will still work. For example, you have, let's say, variable messages, and you have created this variable as list of, let's say, string, anything, right? List of string or anything, let's say list. But if you provide it here, and if you simply provide messages as string, it will not work. It will say, bro, you just said that messages is a list. Why and how can you just provide me the string? I will not take it. But this thing is possible with type dict. That is why, like, type dict is good, but it adds some kind of you can say risk with your state. So if you do not want any kind of risk, Pydantic is the go-to way for your agents. Okay, and I love Pydantic. And if you do not know about Pydantic, do not worry. We are not just using complex things in Pydantic, but in short, Pydantic is just the way to define your schema. Basically, the state that you want this variable of this type, this variable of this type, this variable of this type, and that's it. Cool. So let's try to create that thing. Okay, so we are here, SQL Analyst, perfect. So here, how we can just create that thing? So I can even create one folder called models. And within that, I will create one file, and this will be called as schema.py, because this is a Pydantic model. So if you want to import the Pydantic, you will first need to add uv add Pydantic. And one thing, if you're using VS Code, it's not a big deal. But if you're not using VS, then whatever you are doing, you need to make sure that you are installing every package in the virtual environment like this. By default, it sometimes automatically turns it on, but if not, you have to just write something like this. Let's say .when, then scripts, then activate. Okay, that way you can confirm like this is the virtual environment that you are using. Cool. This is like simple thing, but still. So now I will simply say uv add Pydantic. So this is already added. How? Because it might have added through Langchain module, so it adds some dependencies as well. So in order to use that thing, I need to import from Pydantic, import base model and field. These are the two things that I would need. So I will simply create my class. I will simply say agent state. Okay, agent state. Agent state means this is the state that I'm just creating, or let's say agent schema. This will be like more readable. And within this class, you need to inherit the base model. Base model is the class that we get from the Pydantic. And now I will define all of my schema that I want. For now, I do not have much thing in my mind that I would need in my schema, in my state. But first thing is, for sure, I need messages to store the chat, my message, AI message, everything, right? So this will be of, let's say, list. And I can simply say field. Field is just to provide some context. So I can say list of messages to be processed by the agent. Perfect. And just to make it more readable by the agent, I can use annotated. So I will simply say from typing import annotated. Perfect. What is annotated? I know that my messages is of list type. I know this thing. But if I use annotated, I can simply provide like how this particular schema will behave. So let's say in the messages, I will keep on adding more and more messages, obviously, right? So if I say annotated, and then if I provide list, and this will be of type add. Like, what is this add? See, whenever I just add any message, I know that within my list, I would need to append messages like my message, then AI message, then so on. I need to just keep on continuing the chat, right? Remember? Very good. So when I know that I need to just keep on continuing the chat, I will be adding my messages. So I can simply provide some metadata, some context like this, that this is a list, but in this list, I will perform add operation. Add operation means I will be keep on adding the chats. Simple. When we just use this method, Langchain or LangGraph will automatically perform those things inside the graph. We do not need to manually do it. This is a very good way, but I will just show you the manual way as well, but that's not a big deal. So simply say from operator, import add. Add is the operator that we can just use here. I hope it makes sense. This is not rocket science, obviously. It is like very, very easy. So this is like first thing that I have. Second thing that I just want is my, let's say, safe flag. So let's say if this query is safe or not, or anything, right? Or forget about that thing. We can simply take first of all the prompt query, or let's say what user is saying. What user is saying. So I can simply say user input. Now I can even add this user input. Like I do not even need this user input within my you can just state, because I can store the user message directly in the message, which makes sense. But I want to keep messages as just my chat history, and that's it. I want a fresh user input every time I am just running my, you can say, prompt, any kind of agent. Again, okay, like you can just provide like this. But if you just want to use the messages like with user message, you can simply go with it. It's not a big deal. Okay, so if you just want to, you can just go with it. Not a big deal. So let's say messages is there. So we'll simply keep the chat history directly within that message, and that is good. Again, it works. Now the second thing is I want basically the simply go with architecture, and here is the architecture. Here I want this query is done in the messages. I would need curated query, right? Curated question basically. So this curated question should be saved somewhere, obviously. So I can simply create one state for this as well. I will say curated question, right? And this will be of string type, and the field will be curated question to be answered by the agent. Or I can say curated question of simply curated question. Simple. Curated user question makes sense. Third thing, I would need the prompt query. What is this prompt query? Prompt query is very, very important. Prompt query is your this query, which is this one, that will have context. So I can also write something like, let's say prompt context, prompt query context. Simple. And this will be obviously of string type, and I can simply provide the description as my context for the prompt query, or I can provide some more detail, a detailed prompt with SQL DB context that will help agent to generate SQL query. These descriptions are so important when you're working with LLMs, because LLMs read these descriptions every time. Then second thing I need is safe, which is a kind of flag. So I can simply say literal. So we have Boolean as well, but I like literal if I just just working with this particular state. So let's say literal, and I have two options, yes or no, and perfect. And I can just add this literal as well from typing. Simply say literal. Perfect. So this is my state so far. And what else we can just add? Let's say generated SQL query. So let's say generated SQL query. This is the query which is generated by your LLM, obviously. Perfect. And then I can say result, SQL query result. Like what was the result after executing it? SQL query execution result. Simple. Cool. So this is my schema, and I think this is good. Perfect. And I can simply create one last thing just to serve it. Let's say final response, or let's say final answer. Cool. So this is the state that I just need to travel throughout my agent, and this is the backbone of the agent, because agent will actually perform well because it has this state. That is it. Cool. Now let's try to create our first util function, and in this util function I will create one file called LLM pick. What is LLM pick? LLM pick is the model, basically the class that we just need to build for this purpose. See, when we just go with our architecture, We have low end LLMs, we have high end LLMs. So we need to make sure that we have the exact switch, like quick switch between these things, so that we do not need to hard code this thing again and again. Whenever I want to use, let's say, low end model, I can simply click on that thing and I will be just able to use it. So this is a very good way to create that thing. Okay, so let's try to create it in our VS Code. Perfect. So here I can simply create a function, because we do not need any kind of class for this, because it is like very easy. So I'll simply say pick LLM, and not model name, I will simply say model level, or let's say level. Simple. So now within this thing, I need to write the logic that it will automatically pick the model based on the level value. If it is low, or let's say medium or high, it should just change the behavior, right? Perfect. So we can just add this doc string, because I love adding doc strings in my functions after AI. So this is my doc string. Doc string means like you just add some context, like why we are creating this function. Perfect. So I'll simply say if level equals, let's say, low, right? And I can also convert it into low, like lowercase, lower of level, or let's say level dot lower, just to convert whatever value we are sending as low. If we have this value, then I want to create an object for my, let's say, chat OpenAI, right? Chat OpenAI is the object that we just create, and you would need to call this particular class first of all from Langchain OpenAI. So first of all, let me just do it from Langchain OpenAI, import chat OpenAI. Now, if you are using Anthropic, you need to use just chat Anthropic, and that's it. Okay, both are same. You just need to import this thing, and that's it. And this is why I'm just creating this object, so that you do not need to hard code any Anthropic model in the main code. You can simply change it right here, and that's it. Cool, very good. So let's try to create the client with that particular thing. So I'll simply say LLM equals chat OpenAI, and then model name. I need to just provide the model name, and we can just pick the model name from the list that we just discussed. So go to pricing, and this is the model for the low, Luna. Perfect. And I can paste this name Luna, and I can set the temperature as well is 0. When you set the temperature 0, it will not just pick anything with the highest prediction, because what is an LLM? LLM simply predicts the highest possible, or the token with the highest probability. But this happens only when you have temperature equals to 0. When you increase the temperature, let's say to 1, it can even pick the token with the lower, you can say, probabilities. That's how it works. Okay, if you do not want to play around this creativity thing, simply keep the temperature 0, which is, you can say, recommended when you are performing some coding level things. Perfect. Then if we have, let's say, LF medium, then we can simply go with not Luna, this will be Terra. Perfect. And else, yeah, let's keep high, and let's not go with Claude, we will simply go with GPT 5.6, and then Soul. These are my 3 things. Cool, very good, and perfect. And we can simply say else raise value error, and that this model does not exist, and it will simply return the LLM object. That's how it will work. We can even test it. We can even call this function right now. So let's say I want to create the object LLM object equals pick LLM, and I want to, let's say, use low. Perfect. So now I can just call anything. I can simply send any information, let's say LLM dot invoke, and I can simply say LLM object, and I can say what is let's ask this, because we just need to test it. So I can even print it just to see if our LLM is working fine or not, our APIs are working fine or not. So simply click on this play button just to run this, and let's see what we get in return. So let's wait. I think it is running fine. I think so. And obviously it will take some time, because LLM is generating the response, and very good. Chat Anthropic. So this was just the illustration for you. Obviously we are not using chat Anthropic, so let's run it for one. Now let's wait. And missing credentials. Oh, obviously. Now what is the issue? I want to just ask you, what is the issue? You will say Anthropic, no, this is not the issue. It just failed before that. It is saying that where is my environment variable? I need the API key. But you will say, Ansh, Lamba, you simply created the .env file here. It is here. But yeah, I didn't call it in my main file. So if I just want to call it, I can simply use it from, let's say, .env import load.env, which is a function which automatically creates the environment variables for the values that we have stored inside our .env. Perfect. And obviously we need to add this module. Simply say uv add .env. Perfect. So now when you will run this thing, what it will do, it will automatically create the environment variables for me, whatever I have stored inside my .env. Cool. So let's run it for one more time. Clear. Let's click on this play button. So let's wait. Let's see if we get any error or answer. Very good, we got the answer. So just see the answer. Content is this one. The capital of France is Paris, which is absolutely right. And we used low model, which is like Luna. Okay. And we got some other things as well. Let's say completion tokens was this, prompt tokens 13. So in my prompt, I had 13 tokens. See, 1, 2, 3, 4, 5, 6 words. But within these 6 words, I have 13 tokens, because tokens are like words are made up of tokens, right? Cool. So total tokens will be 25, because completion tokens, that means that the response that it has created, right? 12 tokens, and then 13, total 25 tokens. That means it is good. So this is working fine. So if you have chat Anthropic, then you would just need to use here from Langchain Anthropic, import chat Anthropic, and here you will simply use chat Anthropic, and that is it. Okay, that is it. And obviously you would need to pick the model name. Just for your reference, you can use model name like this. Let's say one model name is, let me just change the, let me just write, I think LLM equals chat Anthropic. I will just comment it out. I'm just writing it for you. And one model that you can just use is Claude Haiku, I think 4.5. It should work. Okay. So I'm just commenting it out, but you can use it if you're using Anthropic model. I hope it makes sense. Okay. And you can use Claude Haiku 4.5, then you have Claude Sonnet 4.5, then you have Claude Opus 4.8, then you have Fable 5 as well. So you can simply search the list. The list is really wrong. So simply go with it. So our object is working fine, and we have already tested that LLM is also able to perform all the things that we want to do, right? Very good. Now the thing is, we need to call this LLM inside our this agent, this schema, right? Which is our this schema. So we'll just call it, obviously, and we do not need to worry like how we're gonna just call it. So it is fine. Now, in order to add this particular, or basically in order to use this utility within my, let's say, models folder, I would need to add this parent directory in my you can say system path. Why? Because think about it, I want to use this particular, let's say because I'll be just running everything in the main like from the main.py, that is for sure, but I would need to run my model from here as like from my agent from here as well, right? Or not from here, let's say from here, same thing from here as well. So now if I will write something like this, let's say from utils import LLM pick, obviously, or I can say from utils dot LLM pick import the function pick LLM, right? This will not work. I can just show you. If I just run this code here like this from this file, this will not work. Really? Yeah. Let me just show it to you. So simply run this particular function. It will say no module found named utils. But you will say, Ansh Lamba, this is the folder. We have this utils. But currently, this Python file is running from this folder, agents. So if it does not have any kind of folder created within the agents folder, it will not detect it. If we want to, like if we want VS or basically this particular project to detect our, you can say, data agent, we need to run this Python file from the root directory as well. And in order to do that, we always use OS module. So let's say import OS. And in the OS module, you can simply write the path. It will be like, let's say, import sys as well, I think. Yeah, import sys. So you can simply say sys.path.append, and I want to append basically the path of my root directory, okay, path of the root directory to my current file. So I'll simply say os.path dot, let's say, absolute file path, if you just want to get the absolute path, and absolute path of which which file, current file. So simply say os.path.join directory name, and with this one. What is this code? This is literally adding this particular directory to my system path for this particular file. Okay, so what is this dot dot? Dot dot means you just need to go one step up, and that's it. Okay, now if I just save this file, if I run it for one more time, it should work. No, very good. One last fix, and we just need to move it before importing it. Silly mistake, but that's fine. That's fine. Now let's test it, and let's see if we are just able to. Yeah, I think yes. Now it is just running this thing. Yeah, perfect. So now that means now we are just able to use and import the things within our agents. Make sense? Cool. So that means our LLM pick is done. Make sense? Now what we need to do within this graph, we need to make sure that we have all of the helper functions available. Cool. So now the very first thing, if I just go to my architecture, I would need to have the question, right? So let's say this is my users, and users will send the query. So here the very first thing is sending this query to the LLM. So let's try to create the node for this. Cool. Let's see. Now you will be very happy to know this thing. Whenever we want to create any kind of node, anything, we simply create the functions. Python functions are your nodes. Simple. Python functions are your nodes. So let's say I just want to create that node. I would just need to create a simple Python function, and that will be treated as my you can say node. But with one thing, I would need to have that base model. I would need to have that schema, because I need to travel that particular thing within my node. So let's bring the schema as well. So let me just say from models dot schema import what was the name of it? It's called agent schema. Cool. So we would need this thing. Perfect. Now we have the schema available. Cool. And we have we do not actually need this object. Yeah, that is fine. So now let's try to create our very first function. So let me just add this code. So AI agent code, so that you can just make sure that you have the clean structure within your script. So I will create this node as, let's say, curate question. Cool. Curate question. I would need one parameter because this is a function. Now this is the step where we need to pass the entire state. Okay, so here we simply create one variable called state. You can just call it as state, because that's how we just create or manage state within our you can say Langchain or LangGraph nodes. So what is the data type of the state? The data type is agent schema. Cool. And what this returns? Again, agent schema, because we should always return the entire state so that it can easily maintain that state throughout the, you can say, nodes. I hope it makes sense. Cool. Very good. Now the very first thing in this node I want to do is I need to extract the messages. If I just open the schema sideways, I have the messages. Cool. Within this message, I have to extract the user message, and by default it will be the very first message. If I just try to find it, that is why I told you, when you are using this way, like messages, when you are just maintaining the chat history, it will be difficult for you to extract the message. Oh yeah, that is why always create this user question as like this. I wanted to show you the problem, then only I wanted to add this thing. Otherwise you will say, hey, we can just add this thing in the messages and everything is good. Not really. Okay, cool. So this is my user question. Cool. So I'll simply say user question equals state.userQuestion. Now why I am using this dot notation? Because with Pydantic, this is a Pydantic, you can say, object. This is not a dictionary. This thing is not a dictionary that I can simply say state of user question like this. Let's say like this. No, this is wrong. We have to say state dot user question. Cool. Because this is a Pydantic object. Pydantic model object. Cool. Very good. So I have the user question. Very good. Now I just need to send this thing to my LLM. Makes sense. So I can simply say LLM object, because I just want to use low level LLM. So I'll simply say pick LLM and then low. Okay. Makes sense. And now I can simply say response equals LLM.invoke, curate the following question so that we can use it. Yeah, simply say curate the following question. It will automatically curate the question. You can provide some context, but we do not need to actually provide any context at this level, because the major context will be provided at the stage when we want to create the final response. Okay, simply user question, and this will create the user question. And let's say what is the state here? We have curate question. So now we need to fill this state, right? Because by default it will be empty. So I'll simply say response equals and state dot curated question, quest or question, quest. Yeah. So let's say curated quest equals response. I hope it makes sense. Cool. And I can just return the state. Why state? Because we need to return everything, because it is a rule in LangGraph. If I just return a specific thing, let's say if I just write state dot curated question, we can do this thing. It's not wrong, but it will not update other values. Okay. Sometimes we need to do this thing, but I have observed whenever you just return the entire state, it makes sense. But in some you can say scenarios, we have to just update the specific state and that's it. When you're just performing concurrency between the nodes, that is a different story. But yeah, makes sense. Cool. Return state. So this is our very first node, which will curate the information, curate the question. Now here comes the second node when we need to provide the context. Okay, let's try to create this node. Okay, now this will be my second node, and I will say prompt. What is the schema name? Let's keep it aligned. So it is called prompt query context. Let's use this here. Cool. And again, input and output will be same. Now the thing is, I need to use first of all curated question. So I will simply fetch that, and just to make it aligned with the function name, so let's use quest only. Okay. So this is my curated question that I have. Along with this curated question, I need something else as well. What? I need schema details, obviously, right? So how we can just create the schema details? Now we would need to fetch the details from the SQL database. Make sense? Okay, cool. And database connection. Where is database connection? Where is the context? You are right. Now we need to create one utility to first of all create the connection. Okay, so let's say db connection .py, which will take care of the db connection. Then we would need to create, or let's say let's create the class here, not just db connection. Let's say database.py. Okay, because this database will be a complete class. Within that we will create the object, connection object. Second, we will also provide how we can fetch the information. Oh really? We need to write the function to fetch all the tables, all the columns, all the demo data, everything. And for that we should first of all have one database. So now we will be just setting up the database. So now it's time to configure our database finally. So how you can just configure database? You will say, Ansh Lamba, where's our database? We will create it, because now our all of the ground level working is ready. Now we can just set up our database. Now the good thing is, here you can literally use any database, any data warehouse, any lake house, literally anything. But as I just mentioned earlier, just for the sake of having one database, I will be using one database that everyone can quickly initiate, configure and do the stuff. But The working will remain the same. You can literally use any database. Okay, so just for the example, I told you I'll be just using Postgres database. So let me show you how you can just download it. So let me just close all of the tabs. So I'll just checking some online links because I already have downloaded it. So what you can do if you do not have Postgres downloaded, simply go on browser and search Postgres download. Postgres download. Perfect. And here you will just land on this page, this website. And click on Windows if you are on Windows, and if not, simply use Mac. And you can just download any version, let's say 17, 18, 16. And in order to just reach to that download page, click on download the installer. Here you will have the entire list from where you can just download it. I would recommend simply go with 17. 17 is a stable version. And I assume that everyone would be using x86 ISA. Some machines also has, let's say the modern Windows machine are also using something called as ARM, which is a different kind of ISA. But if you are just using x86 64 bit, then obviously it should be fine. If you're using ARM based, then I would say simply try downloading it because it is efficient with x86 and most of the machines use x86 ISA. Okay, what is ISA? ISA is nothing but instruction set architecture, which decides like how your CPU will be designed and all everything. Okay, cool, very good. So now simply download this thing, and while downloading this PostgreSQL, it will ask you to download some extra softwares, extra you can say components, and in that component you will see 4 things in total, and 2 are very important. One is Postgres server, obviously. The second thing will be PG admin. So make sure you download these 2 things for sure. The other 2 things are optional, like Stacker and all. You can download it. If not, it's fine. But you need to download both of the things. Cool. Very good. Now I assume that you have this PostgreSQL downloaded. Cool. I assume that. Now, because you have this downloaded, now we can simply open the connection. Basically, you need to talk to the database. You can talk to this database using terminal as well, because PostgreSQL talks to you on port 5432 of your machine. But obviously we need a nice UI so that we can see the stuff. So for that, we'll be using PG admin 4. Make sense? Very good. So let me just open PG admin 4. Simply search on search bar. Okay. And search PG admin. You will see one application called PG admin 4. Okay. So let's wait for it to open. And it is opened here. Let me just drag the screen here. Just a quick tip. If you are using some hosted version of PostgreSQL, or if you are using, let's say, something called as Docker to run PostgreSQL, the steps are exactly the same. You just need to have SQL Server running, and that's it. So let me just drag my screen here. So this will be the interface that you might see. Okay. You can also see some stuff on the home page, but because this is not my first time logging here, so that's why I am just seeing the blank thing. Now I just need to connect to my server. Server resides on my machine and it is running. I know. So now click on this servers. Okay. Currently, it will simply ask you this thing like put the password. In your case, you will not see my database. You might see something else. Okay. You can obviously, because you will see like PostgreSQL server 16, 17, blah, blah, blah. I prefer running SQL Server via Docker. That is why I'm just seeing this thing. But in your case, you will see that PostgreSQL Server 17, 18. And here you need to put the password that you picked while configuring or installing the PostgreSQL Server. Right? Very good. So I can directly put the password. Let me just put it. Perfect. So this is my database and we get default database called as Postgres. You will also get this database, which is very normal. Now, if you just want to, let's say, register a new server, maybe you are using a different database, you can simply click on the servers and click on register server. And here you can simply provide any name, let's say agent DB. Okay. And go to connection. Host name will be localhost and port name is this one. Maintenance database is Postgres, default one. Username is Postgres because I created this username, and password will be the one I picked. Cool. Let's say perfect. Let's say save. So this is my database. See, both are same, but I just showed you the other way as well, how to connect to this thing. And I can even disconnect this one because I do not need this one. I'll be using agent DB. Cool. And here I have these databases. I can just show you the databases that I have. Perfect. So I have Postgres database. Currently, I do not have anything inside schemas. I have public schema only, which is a default schema. Here we will be creating our tables inside this public schema. You can even create, let's say, a new schema as well, not a big deal. And once we have the schema ready, then we will be creating a new user as well, because we'll be using that user to connect to this database. Why? Because it ensures the security. You do not need to allow everything, because currently we have logged in using the root user, which has like everything. It has all of the permissions, literally everything, but we cannot use that particular role to access anything, right? So we'll just create that role, not a big deal. So let me just go back to my VS Code and let's wait for it to open. Okay, so this is my VS Code, and here obviously you'll be just using this database.py file to create connections and all. I want to create one more file which is not the part of the agent, but it is the part of the project, and it's called, so let's say, feed database.py. In this particular file, we will write our data to the database, because I do not want to use SQL queries. I have some CSV files that I want to use to directly insert that data into my PostgreSQL. Makes sense? And I can quickly copy all of the data files inside this data folder, and once we have the files, then I can just write the code here to insert the you can say tables, rows, everything inside the database. I hope it makes sense. Very good. So I have just copied the data inside my data folder, and you will also see this data in the repository. You can also just make sure that this data is here. So now what are we gonna do? I will simply paste the script here, and this script will do nothing. So basically, whenever you want to talk to any kind of database, let's take an example of PostgreSQL. So we need to create a client, right? And because we are using Python, we need to create a Python client. And for that, we have a specific library called psychopg2, and we will be just installing this particular package. Okay. With the help of this, we can easily connect to this or any PostgreSQL database, and then we can perform literally anything. We can execute the queries, we can create the tables using queries, like in short, we can create the client and we can perform everything. In short, let's say I'm inside this PG admin. So if I want to perform anything, let's say if I just want to run anything, right click on it, query tool. So I can just write my query here. Let's say select asterisk or blah blah blah. Let's say select 10, let's say 120. If I run this thing, I will get 120. So what is this thing? This has literally run the query and created the client behind the scenes. But now we are not using this UI, like we use UI to troubleshoot something, but when we are just using a programming language, we simply create the client, same thing. We send the query same way, but without UI. Cool. Very good. So let's quickly, first of all, add the package called psychopg2 binary, and it will take some time. Perfect. So this package is installed. Now we can just use this package in order to work with this. Okay. So this is the script that I have just recently crafted. I also haven't tested it, so I will be just testing it with you. So what this script is doing, literally very simple stuff. Let me just give you a quick walkthrough. First of all, we need to connect to this database. So these are the configurations that we just simply write. Currently, we are hard coding everything here, but ideal way is we can just move the stuff here. So let's say database is Postgres, and let's say host is localhost, and then username will be Postgres. Password will be your password, but in my case it is Postgres, and I just forgot to add s, so now it is this one. Okay, cool. So these are the 4 variables I want to use, and I will simply go to my feed DB, and here I will import from .env. Perfect. Load.env, so that I can just create those environment variables. Now I can just use those environment variables instead of like this. Let's say os.getEnvironment, or you can also use environ, and then you can simply provide the key. Same way, os.environ, then port, and here perfect. So this way you do not need to hard code anything. And if port is not, no bro, we have port. Oh, makes sense. That is a good way, because that was the integer, so that was a quick fix. So very good. We have everything to just configure this database, and my directory for this CSV is data, right? Then what I'm just simply doing, first of all, creating the connection using psychopg2.connect connect, psychology2.connect, then host, user, password, port, database. Simple, very good. Then this is the boilerplate SQL code that you would write to create the tables, like create table, and you already know, like we are just building this particular agent for ride sharing application, right? So we have like users table, and I want to create this table inside the public schema, which is the default schema, right? And our database is Postgres, which is the default database. Very good. Yeah, perfect. So this is my first table, second table, third table, fourth table, and fifth table. And in this, we have just provided the constraints as well, because this is obviously a database. Then we applied some indexes just for the faster query, some performance enhancement, that's it. And then we simply truncated some table if they exist, Currently, I do not have this thing available, but some of you might be, you can say, running this particular thing again and again. So you can run this thing as well if you have tables already existed in your public schema, because it can happen whenever you are just developing anything local, you can have the similar table, like table with similar names. So you can uncomment this section if you want every execution to completely reload the CSV data. But I do not want this thing for now, so I can simply ignore this thing. I hope it makes sense. Okay, so I'll simply comment it out just for you, and if you want to rerun this thing, you can uncomment it. Very good. Then I will simply run this function load CSV table, which will automatically run the loop and then automatically feed the data using copy command, which is your SQL PostgreSQL command. It is not available in all of the SQL servers, but if you are using Postgres, this will be available. Cool, very simple. And then again, same stuff, and it will be like automatically running everything for you using the function. Cool, let's try to run this particular query and let's see, because I have also not tested it. Let's try to run this. Let's wait. If we see any error or anything, we will fix it. Don't worry. So it has started connecting. Very good. Very good. Loaded users.csv. Copy vehicles. Okay. I think something is wrong. Okay. So one constraint is violated. Okay. psychology2.errors unique violation duplicate key value violates unique constraints vehicles license plate key. Oh, okay. We have, I think, duplicate data, and now it is violating that constraint. That is why you are seeing this thing, which is a very good thing. Let me just fix it. So I just fixed the CSV files, and now everything is good. Nothing was wrong with our script. It was just like maybe one record was duplicated 2 times because it is a text file. So we do not have any schema, so it is fine. Now I need to rerun the script, and because I would already have some tables created in my database, so I would need to do a cleanup. So that is why this command will be executed this time. So I have uncommented this thing, right? Cool. So now I will simply rerun this script. Make sure that you have also uncommented this thing. Okay, so let's wait and let's see if our tables are created. Okay, loaded, perfect. So now this time it was really smooth, and I can see that I have 10,000 users, 3,000 vehicles, 20,000 rides, 16,000 plus payments, and 12,000 ratings. Cool. So I can go to my Postgres. So this is my pgadmin4, and let me just click on refresh schema and click on tables. Perfect. I can see all the 5 tables: payments, ratings, rides, user, vehicles. I can also quickly query to see it. Select asterisk from, let's say, users. Let's run it. Oh, okay, perfect. So I can see the data, and we have 10,000 rows, and I can just confirm just to make sure the data was not duplicated. Obviously we had constraints, so that is why I added constraints. That means my database is ready, and now I can simply create the util function, or basically helpers function. Make sense? Very good. So let's jump back onto our amazing VS Code editor. So I will just keep this script for you so that you can also easily feed the values instead of you creating the, you can say, CSV code and blah blah blah. So just keep the script with you. Cool, very good. So this is our database.py. So within this particular file, I want to create a class. So let's say class database util. Let's say, okay, let's say I want to create this class. You can just name it anything. So first of all, I would need to create the constructor. Okay, so I will simply say self and db config. I will every time ask for the db config. I can hard code it here as well, but sometimes you would need to change your database server, right? So you can just simply provide a parameter whenever you want to perform this thing. Cool, very good. So I will simply say self.dbconfig equals to dbconfig. Very good. And self.connection will be psychopg2.connect and dbconfig. And we would need to import psychopg2. So let's do it. Perfect. So we have psychopg2 and we have created this connection. That means this connection is ready. Now this connection can be used anywhere I want, obviously. And let's try to add this try catch method so that if we just find any error, simply go with it and this will be out of this, and perfect. It makes sense. So this will first of all try connecting to this thing. If it finds any kind of error, it will simply say except E and then simply say print this is the connection error, obviously exception is E. Perfect. So just a quick thing, nothing fancy. We have simply added the try catch method. So this constructor is done. Basically, whenever we will be just initializing the object, this will simply enter this dunder method and it will create the object for us. Cool, very good. We can even say return anything if we want to, but it's fine because we are simply using this self variable. Cool. So now second thing will be let's say we want to perform in this database utils. So connection is there. Yeah. So now we want to perform what? The query which will automatically find the context from my database. Okay. So let's call it as schema details or schema info, whatever you want to say. Add self and that's it. We can pass schema name as well, but I would say, yeah, just pass schema name as well. Cool. Okay. Schema name. Let's make it dynamic as well. So this is my function, main function. Now you need to understand one thing, what exactly I need. Let's say I have this schema and this is very important. So I will be just discussing it in detail. Do not worry. You have this schema and you have, let's say, tables within that schema. Make sense? And in our case, we have already seen this schema is public and we have 5 tables. Cool. So first of all, I would need to get the table names from this schema. Cool. After getting the table names, I would need to get the columns, right? Let's say 1, 2, 3, 4, 5, so many of each table. Then I would need to have demo data or dummy data, right? Dummy data, so that my LLM can write better queries. Because when how you write the queries, obviously you see the data first, then you write the queries. So LLMs will obviously do the same stuff. LLMs will read the dummy data and then it can just write the better queries. Simple. Cool. So how we can just first of all see the data. So there is a query called select table or basically table name from your information schema. Okay, how we can just do that? Let me just show you in the Postgres. Perfect. So if you just go to information schema, obviously some of the extra schemas are hidden, but if you will just try to run it, it should run fine. Select table name from information schema. Cool. This is the default schema that you will see with the popular tools like Databricks as well. So simply say tables where table schema will be public. Now why it is important? Because obviously you need to provide the schema name. So if I run this thing, these are all of the table names. Wow. Payments, ratings, rides, vehicles, users. So I will be running this particular query on my util. Make sense? Once I have all of these tables, I will simply run the loop. Okay, I will simply run the loop. Now, after running the loop on each table, I will get basically the columns from those particular table. I hope it makes sense. So let's do it step by step, because obviously I know it is like a little bit complex, but it is very, very important. So let's go there. And first of all, I would need to have the object. And as you know that my object is this one, connection equals self.connection, because I just want to use connection as a variable instead of again and again writing self.connection. So then I will create a cursor. Cursor is the object that we get with the Postgres connection and with the help of which we can run the queries. Okay, so I'll simply say cursor connection.cursor. This is the same cursor that we created while pushing the data to the database as well. Cool, very good. Now I will simply say schema information. Okay, so let's create a blank variable because this will be our entire context. Schema info, or let's say context. Currently it is empty. I hope it makes sense. Currently it is empty. Okay, so I'll simply say schema info context equals what? I will simply say f, which is f string, schema, and then schema name. I hope it makes sense. Cool, like schema name obviously, or you can say database schema information. Simple. So I'll simply say database schema, this one, and \n is very important because otherwise it will like keep on adding everything within one line, which is not very, you can say, readable for us and for LLMs as well. Okay, simply add \n to just go to the next line. So this is my schema name, right? Then I can also write something called as, let's say, table information, obviously because I would need the tables. Okay, so let's try to actually run the query, and the query will be like this. Let's say cursor dot execute the same query that I just wrote here, this one. So let me just copy, let me just paste it here. Perfect. So this is the way I can just write the query. Cool. And obviously instead of just hard coding the, you can say, this schema name, we can also use the f string. Yeah, so let's use it here. So let's say this is public, and let's say schema name. Cool, perfect, because we have schema name, and this is a better way to do it. Percentages. Whenever we want to write or run any query with Python client, we have one option of hard coding it, right? We can save a lot of risk, or basically we can just save a lot of, you can say, attacks just by using this thing, which is percentages. This is also called like query prompting, and you can say SQL injections and so many other names. The motive is very simple. You do not need to directly use your f string to eliminate your parameter or variable. Whenever you want to use any variable, you simply use %s in the cursor and you close the query. Then you add a comma and then you feed that value in the exact order. Let's say you are using multiple variables. Let's say you are using one variable here as well. Then you will be just providing the values in the exact order. Okay, so remember this thing. Whenever you are saying cursor.execute, then you just need to first of all write your query. Wherever you have any variable, simply write %s. That's it, nothing fancy. Then feed that value like this. Let's say schema name. I hope it makes sense. Okay, cool, very good. So this is my schema name, which is very good. So I have this thing. So this will simply return me the tables list. Cool and perfect. So in order to fetch basically the tables list, I can use a function called fetch all. What is this function? This is the function which will convert your records, or basically the result, into the form of list. Okay, so I can even add dot fetch all here at the end here, and the better way is obviously just to use it in the next line just to make it readable, but both works fine. Cool, so I can just use it like this. Perfect. Now I have the tables list as well. I hope it is simple. Very good. So now I will simply say schema info context plus equals table. So what I did, schema info context equals schema info context plus this one. I hope it makes sense. But the thing is, when I just write this thing, just the tables, now this will create the query like this. Let's say schema is public, then it will simply say this is my table name. Let's say users, which is not a good thing. We need to run a loop over table list. Cool. So I'll simply say for table in table list. Then once we have the table in the table list, now what will happen? This table list will have a lot of other information as well. Okay, So we need to just fetch the very first object. The very first object is the table name itself. I hope it makes sense. Okay, table name is the very first object whenever we run anything. Cool, very good. So I'll simply say table name equals to this one, and now this will become my schema info equals schema info context table name, and this is the one. What just happened? Schema info context, which literally had this database schema, right? Then \n, then table. Oh, then it will just put the table name. Okay, makes sense. Now I will run one more query. It's called cursor.execute, select column name, data type from the exact same schema. Wow, same thing, see? And I can even run this query just for you so that you can understand what we just did. So let's run this query, and perfect. So let's say I just want to run this thing. Okay, and information schema.columns where table name is users. Perfect. Run this thing. Obviously here we should see public.users. Perfect. No, oh, I see. So perfect. So see, I just ran this thing, and now it has automatically given me each column name, user ID and its data type, sign up date, data type, is active, data type, and so on. Wow, this way I can literally find every information, and again I would need to use the fetch all, right? So I'll simply say column list equals column.fetch all. Now what I will do, again one more loop inside this, and this time I will simply say column name and data type equals to column. Why? Because they're like two things that we have inside this column. I hope it makes sense. So you can also use 0 and 1 as well, like the same way that we just did here in the table name, table 0, or you can just do it in one line as well, but it's fine. So let's say column name equals column of 0 and data type is this one. And now I can just append this thing like this. Schema info context equals schema info context, which is the existing one, then column name, then data type. Wow. Yes. This way it will literally generate your schema, each table, each column of its data type. And then I also want to perform extra thing just to make my agent efficient enough not to throw any random errors. I want to also provide some, you can say, dummy data as well for each table. Okay, so I'll simply say this is my table. Okay, so now let me just add some comments as well for you. Let's add it here. Wait, let me just add it here. So I will simply say adding columns. Perfect. Columns and data types. Perfect. And here I can say adding sample data. Perfect. So now I will simply say select asterisk from schema name dot table name limit 5. Why? Simple. I do not need all the data. I just need to send some dummy data so that my agent, my LLM, can understand what each column is actually holding. I hope it makes sense, right? And then again sample data, and then I can just simply edit my, or basically extend my schema info context like this. Wow, simple. This will become my sample data, and now I can just run the loop for row in sample data because it will simply return the entire list of records. Wow, this way you can actually do the stuff. I hope it makes sense. Simple. And we just need to return the info schema at the end, obviously. Where is my function ending? So this is my function. Okay, second line. So yes, first of all cursor.close, then return info context. I hope it makes sense. Okay, or let's try to close the connection. I would say in the try except method, which is a good thing. So let's add everything in my try. Try. Yeah, let's add everything in try. Perfect. Let me just hit tab. So just to make our code much reliable, and I can say accept exception as E, and finally connection.close, and return should go here in the above statement. Cool. I hope it makes sense, bro. One more tab, perfect. I hope it makes sense. And return schema, or we can just return here as well, because in the finally it will be obviously running every time. So let's return it here. It's a better one. Makes sense. So try accept finally and then return at the end. What do you want? Do not close the connection here. It should be managed outside this method. Wait, what? If cursor, yeah, cursor dot close, it's fine. And connection cursor dot none. What it was just suggesting before. That's why I just sometimes turn off this auto suggestion. Wait. So finally is done. Okay, if cursor makes sense, and obviously we need to just close the connection as well. So what's the big deal? If connection dot close, simple. Do not manage by database util instance. Database util instance. Oh, okay. Let's check if we are just closing the connection above. That's a good catch. That AI has read my code. Let me just verify it. It's fine. I just close the option, and now it is simply saying that do not close the connection here. It should be managed outside this method, but it's fine. You can simply close it here as well. Not a big deal. Not a big deal. So our connection is also closed like this. And now what we can do, we can obviously test it, like how it is actually performing this thing. So now what I want to do, I want to run this function, and just for the sake of this particular thing, I am simply printing this particular entire thing in the file so that you can also see it. Cool. Okay, so let me just do it for you. So I'll simply say object equals database util, and here I can simply pass the, you can say, your credentials. So I'll simply say user equals Postgres, password equals Postgres without S, and DB name is Postgres. Perfect. So this is my object, and I want to create this object, and I want to call object.schema details public, because schema name is public. Cool. And this will be my result. Cool. And I want to save this result in the file. So I can say with open, let's say test schema details.txt, and let's write result, because I just want to see like what exactly we have got, right? So let's run this thing, because it was actually one of the major things in our code. So I can just see this text file, and perfect, bro. Wow. So we have database schema, we have each table with schema of each table and sample data. Now just tell me one thing, when LLM will be reading this thing, LLM will be so happy to help you, because it has public schema, it has table, it has column, it has data type as well, it has sample data as well. Wow. Now just for those professional people who are like pro developers, they will say, why do we need to send the sample data? So in the industry, it depends. If you do not want to send the real data, the sample data, some teams also create a kind of dummy tables. They create this thing, and it is very easy. You can even ask AI to create the sample data using your original data, but it's not a big deal, because you can just send this data if it is not sensitive to LLMs, and if it is sensitive, obviously your organization will be self-hosting your LLMs. That is common sense. Okay, so this is not the point of discussion, but I know like some people would be like, wow, let me just write something in the comments. Okay, so this is my exact file. Now some of you can also say like, why do we need to recreate this thing again and again whenever we will be running our you can say agent? Very good question, because sometimes some table will be newly added, some columns will be newly added, some columns will be deleted as well. So we need to provide the latest state, latest context to our LLMs. I hope it makes sense. Very good. So now what we gonna do? We gonna finally create our node. Remember our node? So we will be just creating our node using this particular function. Okay, very good. So let's go to our SQL Analyst.py. See, whenever you want to create the agents, it takes so much of efforts. It's not very simple. It is so easy to say, hey, give the prompt to LLM will generate the query, and see, AI proof. I know AI. Bro, hold on. So let's say this is my prompt query context. Okay, this is my node. In this node, we are first of all curating the question, which is this one. Like it is like coming from the previous node, and in this node we are using that curated question plus the context. That is the agenda of this node, obviously. Very good. So let's try to do it. So we have used this curated question. Very good. And we also want to use the messages. So one thing I can just do here as well. So here I will also update state.messages. Currently I know that my messages is empty and I do not have anything. So what I will do, I'll simply say state.messages plus, and here comes the part of add. Remember, I just used add operator in my annotated schema. Do you know what? Even if I just write anything in the list, let's say blah, 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 it will automatically append this thing into my existing list. Wow. Yes. That is the advantage of using add operator. But in some cases, people prefer readability more. So they just simply write it like this, state.messages plus the list. Now we know that messages is a list. So that means I would also need to pass a list. Very good. Now what is this list? This list is holding our chat history. Very good. Now who sent this message? Think about it. It is not LLM. It is human message. It is just curated by LLM. But ideally it is human message. Think about it. Oh yeah. So simply say human message. Okay. And content equals to, you do not need to write curated question. Simply say response. Response. Perfect. Okay. Very good. Now we do not have human message. So we need to import this particular thing. So it is available in langchain.messages, Langchain core, I think. Langchain core.messages, import human message. Perfect. So I have just imported human message. We have three types of message: human message, AI message, system message. System message means you are just setting the theme for the entire agent. Human message means my message. AI message means AI message. And there's like one more message, tool message, which is like we will be just covering later on. Cool. Very good. So I have just appended the curate question to the message list. Very good. Now I have the access to this curated question. Very good. Now I will call one particular utility inside this agent, and that utility is database. So let me just import it from utils.database, import database utils. That is the class name, I think. If I just go here, yeah, database util. Cool. Not utils, database util. So this is the class name, database util, right? Very good. So now what I will do, I will create an object. So let's say db object, and let me just call that database util. And here I would need to pass the connection, right? So let's try to first of all create the connection details equals, let's say host is this one, and obviously it is not available in state, so it is available in our env file. I'll simply say host and then os.environ, then host. Perfect. And port, then user, then password, and database name. Perfect. These are the 5 things. So 1 2 3 4 5 and 1 2 3 4 5. Port, oh, we didn't write port. Wow. Port equals 5432. Cool. Makes sense. Cool. Very good. And we can even write integer the same way we have written here, just to make sure like everything is fine. So port. So this was our port, dbconfig. Okay, dbconfig. Where did we define dbconfig? Just to fetch it. Okay, this one. Makes sense. It is working fine here, so it's fine. Cool. So this is my connection details. So let me just create the object equals db utils and then connection details. Yes, because that's what I want to just pass, right? Because see, in my database, I just need this dbconfig, which is just a dictionary. Same way we have just passed it here as well. Database util, and this is a dictionary. Cool. Very good. So these are the connection details, right? So now what I would need to do, I have this object. So I will simply say schema info equals details, and these are the details that I just want to find. Okay, for the public schema. Now I have the option available, like which schema I want to use. I can even create this schema variable in my state, but in my case, I know that I have the public schema. But if you just want to make it dynamic, you can just add one key in the schema as well, like in this models here, right? But we do not need it. It's fine. Cool. So this is everything. Now I would need to just write one prompt, and this will be like a very detailed prompt. So yes, this is called prompt engineering, and prompt engineering is not a joke, bro, because it actually requires a lot of efforts. So I have just tested this prompt and it was working fine. So this is the prompt. What is saying? It is saying that you are an SQL analyst agent. Your task is to convert the user's natural language. Obviously, you can just read everything. In short, I have provided the maximum detail I was able to. Okay, cool. And yes, I have added one guardrail as well. Unless user explicitly asks for specific number of rows, always limit the output to 10 rows, which is a good thing to save some compute. Note, just generate the SQL query without any explanation, because LLM sometimes just messes up. They just provide some extra thing as well, that here is your SQL query, and then they will just write the SQL query. We do not want that stuff. We just want SQL query and that's it. That is where the role of high-end models come into the picture, because they understand your prompt so well that they do not hallucinate. They do not just provide some garbage that you didn't ask. And these are some properties. Make sense? So within that particular prompt, I have provided the question that user asked, and finally, obviously, the schema info. That means database schema details are here. I hope it makes sense. Okay. Then I will simply change this particular thing, change the key of my state. Okay. So I'll simply say state.prompt query context equals to prompt. That is it. That is it, because I need to update the prompt, right? And now this prompt will go where? This prompt will go to the LLM. Oh, really? Yes. This particular prompt will go to the LLM. But I will create a high-end LLM. LLM equals pick, not low, not high. I think medium is enough, because Terra model is actually very good. Makes sense? So I will simply pick medium. Now I will simply say generated SQL query equals to LLM.invoke prompt. Now I will simply hand over this entire prompt with curated question, with schema info, and then LLM will be able to generate the best query possible, right? And then simply we will get the generated SQL query. I will simply update the state like this, and then return the state, obviously. Cool. I hope it makes sense. Okay, perfect. Very good. This way we have made sure that, okay, our agent can now, first of all, create this particular prompt and then send this prompt to the agent and get the SQL query back. And we are assuming that this query will be very, very good query. Now, what is the next step in our architecture? We need to make sure that the SQL query it has generated is safe to run or not. There are multiple ways to do that. So let's discuss that. Let's say this is your query. This is your query. Now, just tell me one thing. Can I use one LLM here as a judge? Can I? It's called AI as a judge. Can I use? Obviously, I can. Really, yeah. I can literally take the SQL query and I can provide a prompt to AI, and then I can say, hey, could you please say just yes or no? Because I will create a specific LLM, you can say judge AI LLM, which is a special one, because you need to attach one schema as well within that LLM. It's a different one. I will just tell you about this thing. So here I can use AI as a judge just to judge my SQL query is safe or not. But here comes one, you can say, discussion. Some people would say AI just came into the picture right now, few years back, but how we were just configuring or how we were just taking the decision that each SQL query is fine or not? That is a very good question. Very good question. So here we were just using some, you can say, expressions just to find out like, does it contain any kind of special expression? Does it contain any kind of special thing? So if you do not want to use LLM, you can go with the traditional way. But because now LLMs are able to take these decisions, including all of the edge cases, I would say you can just use LLM, but again, it's a personal choice. In our case, we'll be just using LLM as AI judge, because that way you will understand how to build AI as a judge LLMs, because these are the special LLMs where you provide the schema attached to that LLM as well. Okay, so that it will be a good learning for you as well. Very good. And now, yes, one thing that we need to replace, but we have not replaced so far. The one thing is, if you just go to our .env, we are just using the user, which is the root user. We need to just change this user, which is not a big deal. We can just do it anytime. But yeah, we will just do it. Do not need to worry. First of all, we'll just test with this particular user. Then once everything is fine, we can just change this user with the normal user, which only has a read access, so that you cannot simply run literally everything of your choice. Make sense? Cool. So now let's try to create the AI as a judge LLM, which is a special LLM. Okay, let's try to do it. So now let's talk about how we can just create or use LLM as a judge. And this is one of the most important concepts that we just use while building any agentic solution. So let's bring our LLM. Let's use this one. So let's say this is our LLM, and we can use obviously any model. So LLM has the power to actually judge on the basis of some input. Why and how? Because this LLM is trained on so much of data. That is why one of the, you can say, applications of LLM is also the, you can say, like there are so many names to it, but in order to understand it, you can say classification. It can classify it. Earlier, if you have a little bit of machine learning background, you would know that we were just creating logistic regression models, and there were like so many classification models in order to perform any kind of classification, like whether it is X, Y, or Z, right? But now with LLM, we can achieve this thing, because now LLMs are also trained on the classified, or basically data which was like curated for classification. Oh yeah, this was the part of training. So we can just take advantage of it. Here, we do not need to build a special machine learning model just for the classification, which was the, you can say, traditional way of doing this thing. And we do not even need to, let's say, send the data just to train it, because this LLM is already trained. Now, how we can just achieve this classification behavior? First of all, we would need to use the prompt. And yes, with LLMs, prompt is one of the most important thing. And when people say like, hey, you should just go with prompts, learn prompt engineering, people literally laugh. Hey, why do we need to learn prompts? It is useless. You really, if you have literally built any solution with AI, you will feel and you will understand the power of useful prompts. It is very easy to just laugh like, hey, prompts are nothing. We do not need to learn prompts. Why do we need to learn prompts? Okay, build something, you will just understand this thing. So one thing is prompt. We need to simply use the prompt, which is our backbone of everything that we are just working with LLM. Along with this prompt, because prompt is what? Prompt is just the tokens. And when you just provide tokens, LLM will give you the tokens, obviously. So this prompt alone is not enough. Here we need to bring one kind of, you can say, schema as well. So let's say this is my schema, or you can say model, not machine learning model, basically your schema or metadata model. Without this model, this LLM will literally generate only raw answer. But with classification, you would know that we just generate the specific, or you can say, we just generate the value using a subset of values. So if I know that my value should either have yes or no, so I just want my model to have yes or no in the answer, and that's it. And when I just provide this model to my raw answer, or basically not this raw answer, this LLM, this can literally perform this thing very easily, very easily. Why? Because I just mentioned, because LLM can be used with the models in order to provide better answers. Okay, so let's see it step by step how we can just do it. So this is our SQL Analyst. Let me just bring it here. So this is my VS Code editor, and let me just go to my models, and within the schema, I would need to create one more schema, right? And I can create a new class, and I can say judge schema. Okay, judge schema, and I will just import base model class. Within that, I just need two things, basically two keys. One is answer, second one is justification if I want to highlight that justification in my query as well. Make sense? Very good. So I'll simply say answer, and then this will be of literal type, yes, no, and description is indicates perfect whether the SQL query is safe to generate or not. Simple. Yes means safe, no means no. Cool. We will just enrich this thing when we will just add the prompt. And here I can say comments or let's say answer or justification, let's say comments. So this will be the additional comments or feedback from the judge regarding the SQL query. Like this was wrong because of this thing, this was unsafe because of that thing, so many things, right? So this is my class, right? Very good. Now I know that I can just use this class with respect to any prompt, okay? And we would need to first of all test it. So what I will do, I will simply go to my SQL Analyst, right? And here I will simply create one extra Python file. It's called scratchpad, scratch.py. And within that, I can import first of all the models and all, everything. So let me just write all of these things in the scratch, and then I can create the object. Pick LLM low. I think low model should be good. We do not need to actually perform I would say medium at least, because it will take the decision and it would assess the query. So I would need at least some high knowledge within the code as well. Okay, so pick LLM will be this. Now this LLM is created, right? This is the LLM that we were creating before as well. Now what is so special within this? Here I would need to attach my model, basically the, you can say the base model that I have just created. Cool. And I would need to first of all import it. It's called judge schema, and I cannot directly attach this judge schema with my model. I would need to use with structured output. Okay, so I think that library is in Langchain dot I think core. I would need to check. Let me just check it. With structured output class of Langchain, with structured output Langchain. Perfect. Let's see what is the class name. With structured output, where is that? Maybe it would be, I think we imported, yeah. So I think this browser is amazing, I'm telling you. So let me just search. Yeah, I think this is already available within our object, so we do not even need to import it. Cool, that's even better. So this LLM is good. So this LLM object is created. Now I can say LLM judge equals LLM dot with a structured output. And here I would need to provide the schema, like what will be my model that it will just follow. I will simply say output schema equals to just schema. Cool. You can even simply write just schema. It will take that default argument. Make sense? Cool. Now I would need to add the prompt. This prompt is very important because this prompt will guide LLM what to do. Yes, LLM can read a lot of information from here as well, that what this key is doing, what this key is doing. But whenever we are making our LLM as a judge, we need to empower it with the prompt. Simple. So I'll simply say you are a SQL Analyst agent. Your task is to, or let's say SQL Analyst or SQL Judge. SQL Judge for security, for data security and blah blah blah. You can just enrich this prompt. Your task is to determine whether the SQL query is safe or not. You are provided with the user's original query, the not user original query, simply your just SQL query. We do not even need to worry about anything. Because if I just provide the user question, it can actually perform something. So we do not even need to feed user question, which is a kind of loophole in itself, because in the prompt itself, user can just divert the LLM's preference. So simply say your task to determine whether SQL query is safe or not. The SQL query should only be used for data retrieval and should not modify the database in any way. Neither the SQL query nor the prompt should contain any SQL commands that can modify the database, such as insert, update, delete, or any other commands that can change the structure of contents. Respond with yes. Otherwise, respond with no. Additionally, provide comments. Perfect. So this is my prompt and I hope it makes sense. And yes, with some testing, with some more and more iterations, this prompt can become even more and more better. I just wrote it on the fly. And obviously when you are just building production ready applications, you first need to test it a lot of times within your team before deploying it to the production. So make sure it is working fine. You can just involve testing team just to provide some garbage prompts, garbage queries, anything. And then make sure that this prompt is working fine. That's how DevOps actually works, right? So you just need to make sure that this prompt is working fine. That is the part of development that I'm just assuming that you know this. Okay. Perfect. So this is my prompt. Now if I just, let's say, provide anything, LLM judge dot invoke, and if I, let's say, judge 0 judge print, perfect, and here is the prompt. Cool. And now obviously I would need to just provide the query as well. So let's try to have the space for query as well. And I can say SQL query. Okay. And I can just add the query at the end. Your response should be in the following format. We do not need to provide the format because it already has the format. So I will just skip it. I will say here is the query. SQL query to value it. Perfect. And here I can say SQL query. Cool. Very good. And now let's quickly create one SQL query. Anything. Let's say perfect. So I have just created the SQL query, which is very simple, and let's see if it is able to generate the exact response in the exact format that I want. Cool. Okay. So let's try to run this file. Let's wait. And obviously I will just provide some garbage queries as well, just to test it. If it is working fine or not. So let's say cannot access local variable cursor where it is not associated with a value. Why do we need cursor? We do not even need cursor. Database util database.py. Okay. Scratch.py. Line 54. We don't even have line 54. What this guy is doing? Database util. Let me just remove it. Perfect. Let me just run it now. Let's wait. Okay, so capital of what? LLM judge.invoke, and this is my prompt. The query, okay. Content equals to this one, answer equals to this one. Are we running anything else? I think so. I think I know what is happening. Okay, so why I just saw this thing, like the capital of France is Paris, because while importing something, maybe the agent schema or maybe pick LLM, we are running one thing inside that file, and that is also running. See, so we just need to add that guardrail. If name equals to this, then only run that code. This is the behavior that we just usually do whenever we import anything. So what is actually happening? Whenever we import any file, any module, it obviously runs everything. So if we have any kind of object which is running, it will also run that. But when we simply add this dunder method, name equals to main, it will not run this thing if this particular file is being imported. This will only run when we will be running only this file. Okay, cool. So let me just run it again, and I can already see the answer. It is returning me the answer that I just want. So let's see. Perfect. So I can see only two things. Answer equals to yes, comments equals to query is a read only select statement, does not modify anything. That means this is fine. That's what I want. Here I just need to tell you that whenever we create our LLM as a judge, we combine it with the model, the response will also be a Pydantic object. Really, yeah. So if we want to get the dictionary out of it, we would need to use .model dump something. So let me just show you. So this is my response. So let me just say response equals to this dot model dump. Perfect. So this will get the structured output as a dictionary. Okay. Otherwise, this will be a Pydantic object. Good thing to know, right? So let's say print response. So now you will see a kind of dictionary that we can just use in the form of key value pairs in our code. So let's wait. Perfect. Answer equals to yes, comments equals to this one. Very good. If I just provide anything else, let's say delete from something, right? And if I just run this particular thing, this time it should say no, because this is not something that I want. Let's wait. No, the query uses delete. Obviously, this is like a very simple statement. Sometimes people even use like advanced SQL injection to just manipulate something. Either case, this will simply make sure that it is not, you can say, allowing the query because of the, you can say, prompt and the model that we have just defined. Simple, because LLM has the capability to evaluate it. And we are not including the prompt from the user side. That means user cannot even manipulate the model from the, you can say, from the prompt side. That is again one kind of safe side. Second thing, a lot of people will say, we can even create one role which only reads the data from the database, and that should do our work. But do you know what? In the real world, that's like in the big company especially, that's not how things work. In most of the scenarios, sometimes whenever, see, in the big companies, how you assign a role, or basically how you add a user in a specific group, we create something called as, let me just explain that process. We simply create something called as AD groups. AD groups are nothing but basically active directory groups. In the big organizations, we literally have like hundreds of AD groups. And whenever a new user comes into the picture, whether it's a person or agent, we would need to raise a ticket, right? It's called, you can say, service request, a kind of service request. So we need to say that add this user, and in our case, it is agent, to these groups because it wants to read the data from these groups. Obviously, because these groups are created just for the read purpose or blah, blah, blah. But what really happens is, whenever you are just raising these kinds of tickets, there can be at least 1% of error on the implementation side, because the implementation team does not actually know everything that you have within the groups. And sometimes there can be like special requests raised which are not just related to the groups, which are just like, you can say, standalone request for a specific person. So in that particular process, our agent might miss something that it should not. So this is a kind of extra guardrail that we developers need to make sure that it cannot run anything, because data is very important. Data is very important, right? Makes sense? I hope it makes sense. Very good. So this is all about our LLM as judge. So let's create a, you can say, node for this, and we can simply use this code because we have created this thing. So let me just go to my SQL Analyst, and here we have this node. So currently we are at prompt query context, and let me just open the architecture. So, okay, we are here, add context, and the SQL query is also generated. Perfect. Now we are just creating the safe node. Makes sense. Cool. So let's try to create this thing, and this is here, SQL Analyst. Let me just close the terminal. So here I will create a new node. It's called, let's say, df, and this is safe function. Cool. Or let's say is safe node. Cool. So I will simply say is safe SQL, right? And I just need state as my input, as you know, and then agent schema, and returning time will be agent schema. Cool. So here, first of all, I will get the generated SQL query from the, you can say, a state. That is the first thing I need. So I'll simply say state dot generated SQL query, and here I will create this particular, you can say, model. Cool. I would need to import one more thing, which is my model, right, that I just created. So I can say agent schema and then judge schema. Cool. And here, let me just create the LLM object, and I will say LLM judge equals to this. Perfect. And I think it has already read my previous file. So very good to save our time. So I hope it is clear. We are simply doing the same stuff. It has literally copied the code from here, the scratch.py, and literally pasted it here. And at the end, we are updating the state, which is save SQL response. And one thing it forgot to add, because response is actually a kind of dictionary which has two pairs, answer and comments. We do not need to have both the things. We just need to have answer, right? So I'll simply say response of answer. Cool. Makes sense? Cool. So this is return state, and I am thinking just to add one more node. Why? Because in the same node, we are creating or updating the prompt query as well. And we are also updating the generated SQL query as well, which is good, which is not wrong, first of all. But when you want to debug each and every step, whenever something goes wrong with the agent, it becomes difficult. So let's quickly create a separate node for this. So let's say def generate SQL, and let's say state agent schema, and this will literally take this thing, which is my prompt, okay, and return states, and I just need to cut and paste this thing. Cool. And within this, I will simply say my prompt equals, let me just copy and paste it. LLM is this one, and generated query is this one, and I would need prompt. So let me just bring prompt. Prompt is this one, prompt query context. Cool. And I'm simply returning the state. I have just created a different node for generating the SQL, and that's it. Nothing fancy. Generate SQL query node. Cool, because this particular node is updating my prompt, and I am simply using it here, and I'm creating the object, and then simply creating the, you can say, generated query like SQL query, and then updated the state, and then this will simply use it. Same step, same implementation, just I just created a different node for this. Okay, so is save SQL is also done. So now we need to go to the second step, or like let's say next step, which is run the query. Cool. And we will only run this particular query if the answer is yes. If the answer is no, then we do not even need to do anything, and we will simply perform our final response, and that's it. Oh, okay. Makes sense. Okay. And to be honest, this should be actually a kind of conditional node. Let me just explain this thing. So this should run only when the answer is yes. Oh, ideally yes. You are right. Understood. So we should only run this if the answer is yes. Okay. And next step should only proceed if the answer is yes. But if the answer is no, if the answer is, let's say, no, then do we need to run this thing? I don't think so. Right? So here we will not run anything. Here we will simply end the loop, or basically end the agent. I hope it makes sense. And now when we just want to end it, you tell me, do we just need to end it, or we also need to get the answer why it was ended? Obviously we need the answer why it was ended. So we will create a kind of function as well before this. So let's say this was ended, right? Let's say this one, and this will go here in the end, and here we can simply say reason. Okay, or let's say keep this thing and we can just write with reason. I hope it makes sense. So how we can just implement this thing? I would need a special node. It will be like cancelled SQL node, and here we will simply add the comments that LLM provided us. Simple. Cool. So let's create that one as well, and let me bring my VS. Perfect. So is save SQL is done, and here I will simply create def and not execute cancelled SQL node, and here I can say cancelled SQL and state agent schema, and perfect. But here the question arises is how I would know that I have the comments, because I do not have the comments. I just simply deleted it. So I can simply add the schema, like one thing in schema. Where is my schema? Here. And I can say comments as well. Final answer generated SQL. Let me just move it after this one here, and here I can say comments. I hope it makes sense, so that we can just access it just for the stateful orchestration. Okay, so now I can just access it. Cool. and I can simply fill it here, state dot comments equals response of comments. Perfect. And here I can just bring the comments. So I'll simply say comments equals state dot comments, and I can return the final response because I would need to update the final response. So I can say state dot final answer is generated SQL query was deemed unsafe to execute. The reason provided by the judge is this comments. Perfect, right? Because this is what we need to display in the final answer, return state. And then we will simply end the loop. Very good. And here now we can create the functions to run the query, execute the SQL query node. And here this will be like very simple. We just need to run whatever is created, execute SQL, and agent SQL query is this one. Perfect. Connection details the same way. We just need to run the code to create the client and then create the object using connection details. This will automatically construct our object, and then we simply need to say use this execute SQL query, because remember we have this execute SQL function in our util database. And if I just go to execute SQL schema details, okay, so we have schema details. So from where it brought execute SQL execute SQL, okay, database util. I don't think so we have execute SQL. We would need to create one because in our database util we just have two functions, schema details and this one. Okay, so let's create one more function within this and let's call it as execute query. And here what I will do, nothing, just create the connection that we already have, then take the cursor, execute the query, and that's it. Cool, very good. And that's how we can just do it. We already know how to create the connection, how to just this guy is doing. Oh, so it has just corrected my Postgres spelling. No bro, this is the right one. So now this function will be used to execute the query, and this is the query that it will just take as a parameter. Perfect. And it will automatically create the connection because connection already exists here, self.connection, and then it can automatically execute the query, whatever the query is, and then fetch all. You know what fetch all will do, convert the result in the form of list. Then connection.commit, because we usually do not need to perform commit because we are not changing anything, but let's say we are, so let's say commit. Then at the end, cursor.close, connection.close, and return obviously result. I hope it makes sense. Cool. So now, and yeah, for those who do not know this thing, when you return the function, yes, the function will be terminated. But when you have the finally clause, finally is used just to perform these kinds of stuff. Even the values returned, you simply run this code as well. Okay, cool. So this is my SQL Analyst and execute SQL. I do not need any of these things in the connection details because I would need these things. Then I can create the object and then I can run SQL query. Perfect. I think this code is now perfect. So we have the SQL query and everything. So this will generate the SQL query and it will return me the results, right? So I can simply say SQL query execution result, and I do not have any kind of schema for result, if you would remember. So I can create this as well, is save comments. Oh, we have SQL query execution result. Perfect. So this will simply take this value. Now the problem is, if you would remember, in our fetch all, we usually get the list. See, if I just show you the schema, this is string. Perfect. If I just go to, let's say, database. In the database, we are returning .fetch all. And whenever we return fetch all, you will see it here. We run a loop over those things. See? So this is actually a list. So what I can do now, I can convert this thing into a string. So I can say, str of result, because I know that this will be a list. Now it will simply return me the string version of my result. Now I can just send this thing to LLM or anything, right? Perfect. So execute is also done. Now what I want to do, I just need to send the question, the result to LLM just to summarize everything so that it can represent it better. Okay, so let's create this final node. So I will simply say representation node. Perfect. So I will say represent final answer this is my state, and I would need two things. First of all, execution result and curated question, right? And then I can just create the object with not medium, I would say low, because I do not need any kind of high intellect for this thing. So LLM is this one. Let's write the prompt, and let's say you are SQL analyst. Your task is to provide the final answer based on the execution result of SQL query. The final answer should be concise, clear, and address user question. Avoid SQL code. Very good. So this prompt I think is good. If the execution result is empty or does not clear a question, explain. Okay, I think this is good. So here's the execution result. Here's the user's original question. Perfect. So I think I can just add one thing here, \n, just to curate it. Perfect. And here as well, and perfect, because it will just make our prompt look much better for LLM as well. So let's try to simply send this thing to our LLM, and in return we will get obviously the answer, right? LLM response. And here I would just need to add one thing. So whenever we are simply getting the response back from the LLM, you would know that we get a lot of extra information as well, like tokens and blah blah blah. So we need to make sure that we are only fetching the content out of it. Okay, like this will only give us the text value of the final answer. And now we can say LLM, or let's say state.final answer equals to LLM response. Makes sense. And return state. And I think we would need to edit this everywhere, wherever we have this response. So let me just search, and let me just write invoke, hit enter, and perfect. So okay, so this is our very first location. So let me just say content. Very good. And then here, generate the SQL query. Yeah, here as well, because we just need the content. Third, it is fine because this is judge LLM, so this is fine. Cool. So we have provided everything that we want. Okay, now the thing is, I have not updated my chat history here, but I should obviously, because I would need to save the messages. So this will become my not human message, this should be AI message, because this is coming from the AI side, and we would need to import this thing. So let me just add it here at the top, the same way we imported human message. Cool, very good. So our state is also changed, and I think we would also need to update the state in the cancelled query, because that is also one of the messages. State.messages. Perfect. So our all of the chat is also maintained. Now you can ask me, like, Ansh, Lamba, do we need to pass the chat history as well whenever we are talking to this particular agent, like this entire agent? Ideally yes, because see, whenever anyone is asking this agent something, okay, so this agent will do what? This agent will perform all of the stuff that it has, and when it has a chat history with this particular thing, it can actually better answer you everything. Makes sense? Cool. But the thing is, this is not an independent agent, this is a sub agent. So ideally the chat should be maintained at the parent level. Okay, so we do not even need to just send the chat directly from the agent. We should send the chat history from outside the agent, so that it can just inherit that entire chat history. I hope it makes sense, because what will happen, because every time this agent will be called, this agent will get the parameters from the outside, but when we are just running it just for the sake of testing it, we are simply providing it everything. Makes sense? So it doesn't actually matter from where you simply pass the chat history. So in this particular agent, we do not need to pass it, we will simply pass it from the outside. Okay, cool. So this entire node, like the entire set of nodes are created. Now we would need to create the you can say edges and nodes. Okay, because we have simply the functions like nodes, but we do not have any kind of edges, and we always create the edges, and especially the conditional edge, that is the most important thing. So let's try to talk about this thing, because this is very important. So let's say I want to create a workflow, right? And whenever I just want to create a workflow, I would need to import the state graph. Okay, so now let me just search the state graph library for this particular thing, and I think it is LangGraph library. Let me just test it. So let me just write it here. I think so, because they keep on just updating the utilities. From LangGraph.graph, do we have? Yeah, we have graph. Import, not graph, import state graph. Yeah, this one. So I would need state graph and I would need start and end as well. Cool. So I would need these three things. Import from, perfect. So this is done. So now what I need to do, I just need to create an object for this state graph. How? You can simply say SQL agent graph equals state graph, and then you just need to provide the graph that you have just created. And here you simply pass your schema, like you can just pass your schema as well if you want to, and if you just want to provide any special name, you can even do that as well, but it's up to you. Okay, so here I'll simply provide the agent schema, this entire state that we are passing. So I will simply say initiate my graph with this particular state. Okay, so now we will simply define the nodes, and let me just add a very nice, you can say graph building. Cool. So this is my initialization, and then I can say nodes, and with the nodes you just need to initiate, or you can say create an object for each function. Okay, so let's say SQL agent graph dot add node, and here you just need to make sure that you are using the exact name for your nodes. It is not mandatory, it is not a rule, but it makes sure your debugging is smooth whenever you want to debug anything. Okay, so curate question will get the curate question. This is like much better way. Okay, and you can even pass the parameters like this. Let's say you want to create node for this, and then name equals curate question. Okay, this is another way you can simply do it. So let me just do it for all the things. Let's say prompt query context generate SQL, and then SQL is save SQL, perfect, SQL node execute SQL, and then finally perfect. So we have all the nodes, I think 1 2 3 4 5 6 7, all the 7 nodes are here that we have like created here. Okay, so yeah, perfect. So we have everything here, but now the thing is, these are the independent nodes which are not connected. Now we need to connect each node one by one. Here comes the concept of edge. Okay, so I'll simply say edges SQL agent dot add edge. The very first edge always is start, from where you want to start. I want to start my you can say graph with start node, which is the default node created in the class. Then the very first node will be curate question, obviously, because the starting point is curate question. The second thing is SQL agent add edge. Now the starting point will not be start, because start is started. Now from curate question I want to go to prompt query context, obviously, right? After prompt query context I want to generate the SQL. Yes, perfect. Now SQL is generated. Now the next thing is I want to obviously run if this is safe or not, right? Now what should be my edge for this particular thing is save SQL. I do not have only one straightforward edge, I have now two edges. So here comes the concept of conditional edge. We would need to create one conditional edge function here. Oh really? Yes. So let's create the conditional edge function. So I'll simply say conditional edge function. So this will look like this. Let's say is save SQL edge. You will simply give the state, and the return type will be string, not boolean. And I will simply say if, and let's first of all get the response. Is save equals response if is save dot lower equals to yes, then return execute SQL. What is this thing? Execute SQL. This should be your node name. Okay, because whenever we just create the conditional edge function, we should return the node where it needs to go after the evaluation. So I want to go to execute SQL, else I want to return cancelled SQL. Make sure that you are using the exact name for the nodes. This is very important. Okay, so let's try to use this thing. So I'll simply say SQL dot agent dot not add edge. This time it will be add conditional edge or edges, I think. Yeah, add conditional edges. So here it will simply say, okay, I will simply start this edge, but what is the starting point? The starting point is this one. Then you need to run this function is save SQL edge. Then this will automatically create the routes, from that particular node. Wow, yes. And now you just need to add more edges. From execute SQL, it will go to represent final answer, obviously. And if the answer is no, then it will go to SQL agent graph from cancelled SQL as well. Because see, once it is returning is save SQL edge, right? If the answer is cancelled SQL, obviously we need to end it. Oh, and if the answer is execute SQL, then it will go to represent final answer. And then at the end, after final answer, simply end the graph. Okay, that's how we can just work. Make sense? Very good. Some people also prefer writing these two conditions as well, because this will obviously generate two edges. So it is optional. You can simply skip it as well. You do not need to write the conditions for this, like edges for this, because it is already created here. But if you want to, you can even do this. Let's say SQL add edge, and from your is save SQL is it will go to execute SQL as well, and SQL agent to cancel SQL. So this is nothing but just two more edges just for this particular thing, because earlier in the initial versions of LangGraph, this was not internally supported, but then they automatically created the edges for these conditions, which makes more sense, obviously. I hope it makes sense. So for now, we'll simply comment it out because it is not required. Simple. Very good. So our graph is done. Now we need to compile this graph. Okay, so let's try to compile this graph. Compile the graph, and here I can say SQL Analyst equals SQL Analyst graph dot compile. This will make sure our graph is compiled. That's it. What is compile? Compile is compile. It will simply compile the graph. Basically take everything, take the nodes, edges, conditions, and then it can perform the next things. Yes, we can invoke the graph directly, but if you want to make sure that this graph looks fine, you can even visualize it as well. Oh really? Yes, we have some libraries that we can just use. Let me just show you. So it's from IPython. Sometime it does not work, so if it doesn't work, you do not need to worry. So IPython dot, I think, display, and then I think you just need to import display. I don't know, wait, display image, because it sometimes does not HTML, it sometimes does not generate the image. So if it does not generate the image, do not need to worry. I will just show you the alternative as well to this, but sometimes this works, depend upon the server. Okay, so now what it will do, it will simply create the image for you for your graph. Okay, so you simply need to say image, and then you can say SQL Analyst dot get graph. Okay, get graph, then draw mermaid. Now what is this draw mermaid? Mermaid is like very popular, you can say, not a diagram, but kind of diagram that we use whenever you just want to represent the DAGs. There's a website for it as well that you can just use, but I will simply use it within the server. Okay, draw PNG. This will make sure that I have this PNG available. Okay, and I can even save it locally just to show you. Let's say with open, and let's save it as PNG file, SQL Analyst graph.png. Perfect, and write it. So this will make sure that it has this particular thing available in my system. Some people do not even like to have it locally, but if you just want to see it, you can. Sometimes you can even generate the code using notebooks as well, just to show the graph, but you can have the image as well if you want to. Cool. So let's try to run this code, and I think it is just showing here blue. Why? Could not be resolved. Okay, I think we would need to add that thing, IPython uv add. Let's wait, uv add IPython. Okay, because this is a library that works seamlessly with the notebooks, but let's test it with the Python files as well. This should work fine. Cool. So now our graph is by the way done. Now we can literally run this particular graph with obviously one, you can say, response. So let's try to do one thing. Let's not invoke the graph directly, but we can actually, you can say, see the graph, like how does it look like. Okay, so let's only run this code. Let's see if it works. And I have hit the run button or not. Yeah, cannot access local variable cursor where it is not associated with the value. Okay, so I think my database is not running. Let me just turn it on. So now I have simply started my SQL server. It was turned off obviously, so it was saying like I do not have any kind of user, password, blah blah blah. And I just made one more change as well. Let me just show you. In the database.py, I simply extracted these things out, like connection, cursor, schema info, context outside try. So it's not like a very big change and it won't affect much things, but I simply was looking at the code. I was like, let's keep it outside. That's how we can just keep on looking at our code and keep changing the things without any reason. So yeah, so this is my terminal. So let me just now run my agent SQL Analyst and run it. Let's see if it works fine or not. If not, we are the debuggers. Okay, it is running now. Let's see. Oh, I can see one file. Wow, this is the graph. Look at it, so beautiful, but obviously not correct because I can see that cancelled SQL is not directly connected to this one, and I know the reason. I was hoping something would break like here. So nothing big. You just need to uncomment these two things. Really, I was expecting this change because with the previous version of this LangGraph, this change was seen as well. So I was like, maybe it would be changed again, but it's up to them. They own the framework. So let's try to now create it again. I think it should override this file automatically. Yeah, so now it is good. Now I can just see the graph and I can see it everything nicely. See, we have start, curate question, prompt query, generate SQL, is save SQL, and if save SQL is no, it should simply say cancelled. And if this is fine, then it will execute the SQL and then it will represent the final answer as well. That is amazing. Yeah, and then at the end it will simply go to end. Wow. And I can even make it a little bit more clear visually. I can even add here yes or no, but it makes sense. It would go here or here depending upon the condition. It is not a big deal. You just need to add it here, like what name you want to just provide in the form of dictionary, but that's not a big deal. So now it's time to actually run our agent because we are good with our image and everything looks good. So now how we can just run our agent? It's very simple. Once you have this particular thing, and let me even add everything in my main file because that's what I want. I will simply say if __ name main and then only run this thing, because when you'll be just importing this thing, it will again run everything. So once we have the image ready, then I can invoke this function. But before invoking, I would need to have at least one object, obviously. So I'll simply say input schema. And we will need to prepare that input schema in the form of dictionary. For what? For our Pydantic model, obviously. But we cannot directly send this thing to our, you can say, Pydantic model directly. We would need to send this thing as a Pydantic model itself. Oh, really? Yeah. As a Pydantic model, because it cannot automatically understand everything. Okay. So let's provide the messages. And here the messages will be empty. I do not need to keep anything. User questions can be anything. Let's say if we just go to a database, we have, let's say, rides, users, whatever. If I just go to data, I have rides, user, vehicles, ratings, and everything. If I just want to ask what is the average rating for this particular thing, or let's say if I go to vehicles, perfect. How many types of vehicles do we have? Let's say make, or let's say year, or anything. And I can also, like, I can just ask anything. Let's say how many types of payment methods do we have? Credit card, debit card, PayPal, Apple Pay, whatever. So let's try to ask anything. Let's say what are the different types of payment methods we have in our database. Cool. Make sense? Very good. This is the question, and this is the basic question that you can expect from a business stakeholder. It will not write it like this: write a SQL query to fetch the data from the payments table and fetch this column. Obviously, no, nothing. You cannot expect anything from a business stakeholder. You can literally ask a question, that's it. And curated question will be empty because we do not have any kind of curated question, nothing with prompt query, nothing with generated. So everything else will be empty. I hope it makes sense. And then comments, and then SQL query execution result as well. So everything else is just empty. I hope it makes sense. Okay, cool. So now let's try to simply use this input schema and let's try to invoke it. So let's say execute the graph, and I will simply say final response, or let's say SQL Analyst response equals SQL Analyst dot execute. Here you need to make sure that you are picking the right name, and this is the name that you just created for your compilation, because this compiled graph will be the one which will be executed. Okay, but this thing is optional, obviously. If you just want to look at the graph, if you do not want to look at the graph, you still need to compile the graph. I hope it makes sense. Okay, cool. I can simply write it optional. Perfect. So now let's do one thing. Let's try to run this graph. And let me just write clear, and let's click the play button, and let's see what happens with our graph. And I can expect 1 to 2 errors. Compile state graph has no attribute execute. Are you serious? Are you serious? So this is compiled. Okay, SQL Analyst dot, oh, obviously it is not execute, it is invoke. It is invoke. Makes sense. And yeah, and I was saying, like, I can just expect some errors because we didn't even test any of the functions. Yeah. So we got something broke task with curate question, and I think this is not even an error. It is simply saying that broke task with before task with curate question. I think it simply picked a wrong task name. So where we have curate question, so this is my function. Okay, and then it is using it here. Makes sense. Curate question 1 2 3 4 5. So okay, everything else is good. So what you're saying, failed requirement type missing, input value messages user ID. Okay, so it is saying field required. So it is not an error on the code side, it is the error on the Pydantic side. See, one validation error for agent schema is safe. So that means we didn't even provide anything for is safe. Is it? Let's check. That's what it is saying. I don't know. So is safe SQL response. Okay, and what is the schema? Let me just bring the schema. Is safe. So it is not is safe SQL response, it is just is safe. So that is the issue, and that is the issue you will only see with Pydantic models, and this is the intentional issue. You should see these issues, otherwise. Okay, is safe is this one. State dot is safe SQL response. Okay, is safe. Where is safe SQL response? Where is safe? Is safe SQL. There is no is safe SQL response. Understood? Where is safe SQL response? Is safe SQL response. It is just is safe. Perfect. Not response. So this was just a validation error, not even the error on the utility side. But let's see. And this is the stage where we need to debug so many things. So not a big deal. Input should be yes or no, literal. Okay, makes sense. So it is simply asking us to provide the yes or no value. We cannot leave it empty because it is a literal. Very good. And I wanted to see you to see these errors. You will not see these errors with typedict. You will only see these errors with the Pydantic. Makes sense. So that's make your agent more robust. So let me just say by default it should be no, by default, because obviously we are changing it here, which is the answer itself is safe. Perfect. And we do not even need to worry about what is the answer before. And is everything good? Is safe SQL? Yeah, what you were suggesting is safe. Bro, why are you just suggesting me this thing is safe SQL? It is just is safe. Why are you just suggesting again and again this garbage stuff? is safe. Run this. Let's wait. Let's see more and more errors, because this is the time to fix all the things. And we have DB name. During the task name, we have prompt query execution. Okay, prompt query context, key error DB name. So it is not having DB name. Okay, that makes sense. Let me just go to the database, and here we are DB config. Okay, DB name, key error DB name. Okay, so we do not have DB name. What do we have? We have database. Who is using DB name? Who is using DB name? Let me just fix it. DB name. It is not DB name. It is database, bro. Or let's say DB name here, because this is the property, and let's use it here, database. I hope it makes sense. I hope. See, these errors are like very, very childish. I'm not expecting these errors. I'm expecting big errors. Big errors means like some kind of logical failure, something like that. These are like very, very childish errors, like mismatch and all. Key error DB name again. Where do we have now DB name? Key error. Let's change it. Key error. Okay, environ DB name. I think we have more DB name. 3 of 3. 1 of 3. Oh, here as well. Database. Now let's, and I can even fix all of these errors just in one prompt, because I have agentic ID, but I want to fix the errors with you, because you will also learn how to debug the things, and you will also see why AI is booming, because this can all like solve all of these childish errors in just one prompt. Not a big deal. This is good. It is saying during task name is safe SQL. Attribute agent schema object has no attribute is safe SQL. Obviously, now where do we have is safe SQL? 1. Okay. Is safe SQL, is safe SQL. Okay. Is safe SQL. Okay. So this is the function name, which is not a big deal. Is safe SQL, is safe, is safe. Okay. Because it is complaining about the key error on the is safe SQL. So during task with name is safe SQL, agent schema has no object, has no attribute, is safe SQL response. Is safe SQL response. Okay. Makes sense. State dot, oh, makes sense. See, we just change it at one location, and now all of them are fixed. Clear, clear, clear. Let's see more and more errors. This is the time to fix the errors. Finally, after the development phase. Database util has no object. Execute SQL. I think we do not have execute SQL. We have execute query, if I'm not wrong. Schema details, and we have execute query, but let's make it as execute SQL. SQL Analyst, and here we are using, I think, execute SQL. Yeah, perfect. Now once more, and do not feel like why I'm just seeing these much of errors. This is the reality of building the real world project. I cannot just hide the reality. This is the reality. We just face errors and we fix it, and that's how we get the answer. Simple. And now it is saying that Langchain graph.errors invalid update error at key user question can receive only one value per step. Use an annotated key to handle multiple errors. This is a good error. Okay, what is this? This is a very good error. This is a logical error. So now what this thing is saying, it is saying you cannot update the same key concurrently. Like, it is not saying this thing, but I know this is the reason behind it. It is saying langgraph.errors.invalid update error at key user question. If I just go to user question, I should see that thing. Can receive only one value per step. Oh, so that means we are maybe providing multiple things at one step. Maybe, yes, let's see. So user question. So where we have user question, I think in the very first step. So if I just go to the first node, which is curate question. So this is user question. state dot user question equals to this one, right? And then I'm simply sending this thing here, which is curate the following question, user question dot content, and that's it. I'm simply returning a state. Now the thing is, because I might be changing multiple things when I'm just returning the state. This one. Okay, what does it mean? So whenever we return the state, you understand one thing, that first of all, let me just clear the things. Whenever, and this is a very good error by the way, when I just got it for the very first time years back, I was like, what is this thing? And when I just actually debugged it, I was like, wow. So the thing is, let me just create it on the whiteboard. So where is my mic? So what is happening right now? Let's say you have this node which is called isSafe, right? isSafe is again routing, or you can say derouting your graph into two nodes, which is your, let's say, execute, obviously, and the second one is end, right? Yeah. So now the thing is, because this is returning the state, okay, this isSafe is returning the state. State, okay, isSafe is returning the state, and obviously this will also return the state. Cool. Now what is happening, if I just look at my graph, if I just look at here, where is the error? Let me show you again. So this is saying that it is updating all of these things, like all of the state, or it just took one example, which is user question, but actually the issue is with everything. It is saying that state is being updated multiple times. But how? Just look at our graph. Okay, this is my graph, and here from isSafe SQL, two parallel nodes are actually going. Okay, two parallel nodes. So at the same time, this is returning state, this is returning state. That means this state is updated, this state is updated at the same time. So there are basically two states are being updated automatically. Oh, so it cannot perform the update of the same key if it is not a list, because if it is a list, then obviously we can annotate it, we can add more and more values, that is fine. But if it is not a list, if it is just a string value, it would be confused which value is correct, because both the values are coming in parallel. So the fix is where? It is here in the condition. Okay, like those two conditions. Okay, so what is the thing? We first of all need to understand that we can define these two things, but because our state is is designed in such a way, we cannot actually update the state in parallel. So what we can do, we can comment these things out, and we can inherit, or you can say enhance this thing. How? So basically what we need to do, this is our SQL function that we have just created. After that, we need to define the mapping. How? So I'll simply say, if the output of my function is execute SQL, then simply go to execute SQL node. If this is cancelled SQL, then simply go to the cancelled SQL node. Oh, this is the way. This is the way. Okay, and because you can just use this kind of mapping, which is recently newly added, like not newly added, it was added I think last year, but yeah, it was not there before. So now, because I can just use this mapping, I can just add yes or no here. This was the thing I was just discussing before, but I didn't realize that I am not passing the response in my user question and not in messages, because usually we just pass it in the messages. So what I can do in the isSafe SQL, I can literally return yes or no, because that way we will have a better graph. Let me just show you. Let me show you the current graph. Let me just execute it without the invoke function. So let's have it like this, and let's see the new picture, if it is able to generate this graph. Let's see. Let's wait. Okay, perfect. Let me just open it. So now you can just see the dotted lines. These dotted lines are nothing but basically your conditional lines. I hope it makes sense. So you can even say yes or no, but even if you do not say yes or no, you know, like these are now conditional. These are not like now have to run in parallel. No, these cannot run in parallel. So this was the only thing that you need to understand. And this was a thing that you would only learn if you would see the error. Okay. Now let's see if everything is fixed, or we need to learn more things with the errors, because errors give you a lot of learning. I don't know how many of you will understand this thing, but yeah, it is the reality. If you do not see the errors, you would hardly learn anything. So that is the point I would need to make. So let's wait. And now, oh, bro, now it ran fine. And I think everything is, else is good, but because we didn't print anything. So let me just print the response as well. Print prompt response. So now it's time to run our model again, basically agent again with the print statement. And I would just need to make one more change here, not change. I would simply return only the messages, because I know the entire schema will be so long, because we would be having detailed prompt as well, and we do not need that prompt. Like we can see that prompt if we want to, but we do not want to see it right now. Okay, so what I can do, I can literally print it, let's say one by one. If we just want to see it, let's say first of all I want to print this message, and then let's say print some characters, and then we can say if you want to see the let's say not final answer, because it will be in the messages, I want to see the generated SQL query. Perfect. And then I would also need to see the result. Print not SQL Analyst response, not is safe. It will be, let's say, SQL query execution result. This is also very important. And then at the end, we can just check the prompt. Cool. Let's say prompt query context. Perfect. So let's try to run it just to see the things one by one, what exactly we do have in this particular agent. So let's see if we are able to fetch the data and obviously the final answer. So let's wait. And wow, I can see a lot of things. So let's go on the top. So first of all, we have messages, human message, which is my question. Makes sense. I have this particular thing, what different types of parallel payment methods are stored in our database. Perfect. Then some metadata and all. We do not need this thing. And then we have so many human messages, because it will be going in a loop. That is why you are seeing so many human messages, because every state will have that particular thing, right? So that is why, not a big deal. And then I can see the AI message as well at the end. AI message here. So database stores these payment methods: Apple Pay, credit card, debit card, Google Pay, PayPal, and blah 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 blah. Then I have this query which is generated by the LLM, which is exactly correct, with the right column names, with the right schema, with the right table names, obviously. And it is automatically using limit 10 because I asked it to perform this thing to reduce the compute storage. Okay, or like compute. Then it has already given me this thing, which is this one: Apple Pay, credit card, and blah blah blah. And what is this thing after asterisk? Oh, SQL query execution result. Makes sense. So this is the result that we have got from sending this query to the SQL database, and database send this data back to us. Simple. And this is our final prompt that we generated. You are a SQL analyst, database schema details, database schema public, table names, demo data, everything else is fine. Amazing. So that means it is able to perform every single thing that we have just created. And congratulations, your SQL Analyst agent is ready. And it is not just ready, it is working absolutely amazing. So this entire agent is ready. Are you happy with this agent? Because I am very happy with this agent. Very good and well done. So now it's time to discuss our next agent, or you can say next sub agent. Okay, so what is this agent? Everyone knows it is a ETL Analyst agent, or you can say ETL agent. Why to use again and again analyst, obviously. So ETL agent. Now what this agent will do? Let's bring our agent. So let's say this is our agent. As we all know that a data professional, or let's say a junior data professional, or let's say data analyst, would spend a lot of time in extracting the data from, let's say, so many sources, right? And just for the sake of this example, we will use one source, but you can apply that particular concept with any source, because under the hood, just think about it. Let's say you have any source, okay? Let's say a kind of API, anything, right? let's say you have this API. So what this agent can do, agent will have this particular graph. Let's say you have the source. Again, you can have any source. I'm again repeating, because why I'm saying any source, because with you can say Python, you can literally create the client to any client with any source. It can be an API, it can be a kind of data lake, it can be anything. Obviously, because in the data lake as well, data is exposed in the form of APIs. So mostly you will use APIs in order to fetch the data. That is why I have used this as a source. Cool. So what I will do, I will fetch some data from the APIs, which is a kind of extract, right? And I will create one agent to perform this thing, to extract the data from a source. Make sense? Okay. And then there will be one thing to load the data, to store the data. It can be a file system, it can be again data lake, it can be anything, right? In our case, we will just use file system because we are just developing everything locally, but you can literally store this thing to a data lake as well. Not a big deal, but this would require a cloud account, obviously, and obviously not everyone has a cloud account. So that is why we are not discussing with the cloud, but I will explain it in such a way. I will develop this thing in such a way. You can just apply this thing anywhere, cloud, on-prem, anywhere. Okay. That's not a big deal. And the third thing is, which is your, let's say, transform. And then the third thing will be your transform. So let's say you just want to perform some transformation, and do we have pandas? I think I had pandas icon as well. I think so. No worries if they have removed it. We are good. I think I had one. Do I have? No. So we do not have it. Let's say Python. We have Python. So we will clean our data as well, and more specifically, we will be using pandas, obviously. And you can here use polars as well, any kind of data transformation package of your choice within Python. Cool. So this is a kind of ETL pipeline that a lot of junior data professionals, data analysts build on a day-to-day basis, and they just keep on performing these things on demand, because obviously these are not your full-fledged ELT pipelines that data engineers build. These are ad hoc pipelines that business stakeholders ask them to run on purpose. It can be to update one CSV file on which they have built one dashboard or report. It can be an Excel file. It can be literally anything, maybe a kind of data or any kind of repository, maybe a SharePoint, to update the files. So these are not like your full-fledged high-end ELTL pipelines that data engineers build. These are like on-purpose ETL pipelines that junior data professionals, or let's say data analysts, build, right? So now we will be building agent for this thing, and agent will make sure this thing automatically. And why this agent is special? Because in the previous agent, we learned how to build the stateful agent, because we were just taking care of the state in every single node. This is not that particular agent. This is also called as React agent, or there's a very popular name. You can say evaluator or blah, blah, blah. People just keep on saying so many things. So let's say React agent. Okay. Why it is called as React agent? Because React agent are basically tool calling agent. Now with this structure, with this architecture, the special thing is this React agent will obviously talk to the business stakeholders. That is for sure. That is not changing. But the good thing is here we do not need to maintain any state. Okay. Here user will simply come to the agent, and user will say, I want to fetch this data. Can you do it for me? Agent will say, yes, I can do it for you. And it will use this particular tool to actually perform the thing. Very good. Then user can come and say, could you please transform the same data that you have just extracted? Agent will say, yes, I can just use the transform tool and I can just do the work. So in this particular architecture, agent uses these tools automatically, and this will run in a loop. So let's say this will be the call, and this will give the response back like this, then this, then this, then this, then this. So this will keep on running this loop until this agent provides the user with the final answer. This is called reasoning plus acting. So let's say user mixes up so many things within single prompt. I want to fetch this data From here, I want to load it here and I want to transform it as well. I want to remove nulls from my data. I want to do this. I want to do that. Right? Now, React agent will simply look at the list of tools that it has. Okay. This is obviously under the hood the LLM, right? So let's try to dismantle it. So what will happen? This agent is just the agent that you have built, but under the hood, this will be one LLM. Cool. And now this LLM has the access to these tools. Okay. Make sense? Perfect. Now LLM has access to these tools. That means LLM knows that I can use these tools, but LLM never makes these tool calls. Oh really? Yes, never. We build that particular structure. Okay, we build it. So this user will obviously go to this LLM, okay, under the hood. So LLM will say, I want to use, let's say, extract tool. Simple. Then this agent, or you can say the architecture of this agent, will make sure the moment LLM asks for the extract tool, this React agent will automatically make the tool call, or you can say function call, to this particular extract function, and it will get the response back, and it will add that response back in my LLM response, and LLM then execute it, then LLM reason it, and then it will act it. Do I need to make more tool calls, or I am good? If I am good, then obviously I will simply return the result back. Simple. I hope it makes sense. Make sense? I hope it makes sense. This is a structure. This is called React agent, or you can say tool calling agent. Okay. Here, yes, you do not need to maintain the state, but here you need to make sure that you have all of the things. All of the things. Here the best thing is, you do not need to maintain the state, but again I'm repeating, here you need to maintain these tool calls at the right time. Oh, okay, yeah, that is the only difference, and that's it. Okay, makes sense. So we will be just building these particular tools, and the major, you can say, the piece of work that we need to do is these tools. Once these tools are built, then we can easily integrate these tools with the LLM, and then LLM will be combined or basically binded with these tools, and then this LLM will automatically make this particular agentic loop under the hood. Wow, this is a structure that we need to build. Let's try to build it step by step, and let's try to learn everything that we can just learn. Let's see. So I'm here in my VS Code editor, and now we're gonna just build this agent. Cool. So let me just quickly do one thing. Let's go to agents and let's create a new agent called ETL Analyst. Okay, cool. So this will be our file where we will write our code for the agent. Okay. And as you know that we always create the utils function, or basically utils class. So we would need to create some utilities, obviously. And before that, we would need to create or basically set the schema for our agent. In this agent, the schema will be like very straightforward. Here we can simply create a class called as, let's say, class ETL agent schema, and let's say base model. And because this is a React agent, we do not need to carry any kind of special state. We just need to carry only one key, which is messages. And here we can simply say messages, list of messages processed by the ETL agent. Makes sense. That is it. Yeah, we just need this one single key, and we are not worrying about anything else. Okay, so now the schema is created, right? And now we can just import the schema, obviously. Now we need to create the utils function, basically utils class. So here we have database, as you know, right? And similar to this, we will create one more utils. Let's call it as ETL tools, because the thing is, we will be writing a lot of functions, right? Helper functions, in order to hand over all of these things to our agent. And these functions are nothing but just your tools. Like, you will just hand over these tools to your agent. Okay, makes sense. So now, first thing first is I would need to create the class. Okay, and we can just call it as, let's say, ETL class or anything else. Like it's up to you. You can just call it anything. But the main thing is that I just want to highlight here is we will be creating functions first of all for extract. Let me first of all create the class ETL tools, and here for init, let's say nothing, because for now we do not have anything to initialize or to construct. Let's say def, and I want to say extract load. What is this extract load? So basically in the ETL, the major thing that we need to do is data extraction, obviously, right? So data extraction, we need to just load the data, extract the data, and then obviously load the data. Now the thing is, whenever you want to extract the data, there can be so many functions, because you can extract the data from API, you can extract the data from databases, you can extract the data from, let's say, any data lake, anything. So here we are just taking an example of API, because API is something which is like so popular, and most of the time agents like work with APIs more. So we'll be simply fetching the data from the API. But if you want to just add more and more extraction tools, you can add it. Simple, it's up to you. Now, because this function will be used as a tool. So if you would remember, I just told you this thing in the beginning, that whenever we want to create any tool, any function which will be used by the agent, we need to pass a detailed context in the function itself. Okay, so here you can just provide some context. Let's say this data, this function, or let's say this tool extracts this function, or let's say this tool, because eventually this will be converted into a tool. So you can also write this tool extracts the data from the API or URL and loads it into the, you can say, desired location. Okay, it can be a database, it can be anything, into destination. Makes sense? This context is more than enough. Then another thing that you would just need to provide is arguments. Currently we do not have any arguments, but we would need to provide it, right? So first of all, I will be just using a URL from where I want to fetch the data, and it will be string, right? And then destination, like where I want to put my data. Let's say output folder, or let's say anything else. Okay, output folder, cool. And let's use a string format, and that's it. So these are the two variables that I just want to provide. I need to pass the context for this as well. Really? Yes. It's optional, by the way, because obviously agent can read these arguments, but it's always cherry on the cake whenever you write the arguments as well in the context, because that way your agent would not be confused like whether to call this function or not. Simple. So I'll simply provide that I just need these two arguments. One is URL and second one is output folder. Simple. And then returns is optional. It's not a big deal, but if you just write it returns, it's obviously good. So I will simply say return string, because it can be a kind of flag that, hey, this data is extracted, loaded, blah, blah, blah. So this is the context that we always provide to any tool that we just create. I hope it makes sense. Very good. Now what we need to do, we first of all need to set the project root. Why? Because obviously we would need to write the data somewhere else, and I want to write my data, let's say, here in this data folder. Makes sense? And you would already know how we can just perform this thing. So let me just copy the code for that. We can simply perform this thing using import OS. Same thing. I have just literally copied the same code from the previous file. Nothing fancy, nothing fancy. So this is my new output folder where I'm simply trying to write my data from this particular root directory. I hope it makes sense, right? Very good. Now comes the main thing. Now we need to fetch the data. You will say, Ansh, Lamba, where is the data? Like, do you have any API? Obviously, I do not have any API, but I have some public API. I can just show you. And you can literally use any public API if you want to. So this is the public API. This is nothing but just a, you can say, Pokemon API, where it just gives you a lot of Pokemons with the image, with the name and blah, blah, blah. You can literally use any API. I just wanted to use one API which can be accessed by anyone, because if I just use any API with bearer token, a lot of people can just actually suffer while creating or generating the bearer token, and obviously it can just put hurdle without any reason, because here you do not need to configure your source. You will get the details, all of the credentials, everything from the source itself whenever you just want to fetch the data, obviously. But here, let's say you are just using this API and this is the URL that I just want to use. Cool, very good. So first of all, I will just pass this URL as a parameter, so I do not need to actually worry about anything. Here I will simply write the logic for, let's say, for URL in URLs. Why I'm just creating a loop? Because I can expect multiple URLs as well in one time. Like, let's say I just want to fetch the data from multiple URLs in one go. I can actually do that as well if I want to, but if you do not want to do that, it's fine. You can simply run one loop. So it's up to you. So let's say we are not running a loop. We are simply fetching data from the one URL at a time. But I just wanted to show you that you can even run the loop as well. Cool. So let's try to write the logic. So let's say response equals request.get, and we would need to import that library. Import request. So this is a Python library, or you can say Python package, that we use to create a client to any API. Cool, very good. So response equals raise.forStatus if it has any kind of you can say sophisticated status specific to, let's say, 401, 404, all of those, or even 500. So first of all, I would need to get the file, or let's say data. How we can just get the data? You can simply use a function called, let's say, .json, and this converts your data into kind of JSON, because response will be in the form of, you can say, string. So let's say data equals response.json. This will convert everything in the form of JSON. Now that means I am holding everything in this variable, in this data. That means now I can just write this data, obviously, but here I do not want to simply write the data as it is. Why? Because once I have the data, obviously, second thing I would need to do is file name. Okay, yeah, file name. So here what I will do, let's say I just want to write any you can say data, I would need a file name, obviously. So you can even hard code it, and you can even ask the person to provide us the format as well. It's up to us, like how we want to just do it. Okay, cool. Okay, so if I just ask the format as well, let's say I want format as well, format string, and we do not need to define any kind of default value, so it's fine. So I just need format as well. So let's say file name and os.path.join output folder, extracted data.format. Do we have extracted? Yeah, makes sense. We can just keep extracted data. It's fine. But if you want to ask this file name from the user as well, you can just add one more argument, and that's it. And you can even generate one, you can say, random name as well using UUID. It will generate a new file name every time, but it's fine. It's fine. We do not need to make it very, very complicated. It's fine, because you can literally do anything. So once we have this thing, then we can obviously do the stuff, and os.make directories, and obviously if it doesn't exist, it will first of all create that folder for us, right? Now, how do I need to write this data? I can literally write this data using the file operation as well, as you would know, but I want to use the pandas library, because what will happen is, because you are a data professional, okay, and you should know like how to use pandas within your agent, because with pandas you can actually manipulate the data frame as well, which is a good thing. Okay, so I'll simply say df equals pd.json normalize, which is a function within pd, like pandas, and you can simply pass your data as it is. Now this will convert this data frame, or basically this data, into a data frame. Cool, very good. And I will need to import this as well. Import pandas as pd. If it is not installed in the environment, you can simply perform uv add and pandas. If it is not, if it is, then obviously it is good. So let's wait on uv add pandas. Yeah, I think it is installed. So if it is not installed in your case, you can simply add it. Simply say uv add pandas. Okay, and then perfect. So it is saying if format equals to CSV, then simply say df.toJSON.toCSV. These are the functions that we just simply use. And we can also write one more for Parquet, because Parquet is like another very popular format that we use in the data domain. So Parquet. So if it is done, then it will simply return data successfully extracted and saved to file name wherever it is saved, except it will simply raise the error. I hope it makes sense. This is our function, and we can obviously test it if we want to, and I think we should before actually creating a mess within the agent. So now what I will do, I will simply create an object of this class ETL tools, and I will simply say obj.extract load, and I have the URL, which is this one, Pocky API. This is a very popular open source API if you do not know, and I want to provide the folder as data, not data, because in data I already have some files. I do not want to mess with it. I will simply create another folder within this data and then API, or let's say extract. Simple. And I want to create a CSV file, so that makes sense. And here I can print this as well, and perfect. And just to make it nicer, we can simply use this. Perfect. So we have this thing. Let me just run it just to check if we are able to run this data, because obviously this function will be used by agent, but first of all we need to verify if this function is working or not, right? If we have any errors or anything. So let's wait, let's see how it works. And okay, data successfully extracted and it is saved to data agent and blah blah blah. Should I check? Yes, I can see the data here. But I'm not seeing the data in the form that I should, because it has abilities, base expression forms and blah blah blah, ability name. Because see, I know the issue. Currently we have everything here, and what exactly we need from this is, here we have actually so many keys, so abilities, name and blah blah blah. So I think the parent thing that we need is abilities, because within the ability we have like ability, name and blah blah blah. So let's try to go inside this. So if we just go to our VS Code, and the thing is we are simply normalizing the entire data, and we do not want this thing. We simply want to, let's say, normalize abilities, because we have this abilities. Let's try to see this thing, because whenever you just fetch the data, you can actually see this behavior a lot of times. So now we have this thing, okay, is hidden slot ability.name, ability.url. Okay, so we have ability.name and ability. So we were able to actually go inside this ability, so that is fine. That is fine. Now we need to just check how we can just fetch the name and URL, because this is the main thing that we need. Name, URL, name, URL, name, URL, right? So let me just check. From here, you can simply remove one, and then you will just see all of the Pokemon names. Just change, because that was like a kind of, you can say, URL parameter. So that is why you were just getting that conditioned output, but I think that should be good. So here, if I just zoom in a little bit, here you will see that we have all of the Pokemons available here, and the results key, right? So we just need to fetch this results key. Let me just do that. So I have just changed this thing here, data of results, and we would just need to change the URL as well. I think slash is enough. Yeah. So let me just try to run this URL now, and let's see if we get it or not. Let's see. So is it working or not? Oh, I think it is done. Let me just check. Extracted data. Perfect. So now I can see all of the Pokemons, all of the 2021 Pokemons, whatever we have here. So that means this function is able to extract the data and load the data into the CSV format, right? You can even load it in any format, let's say Parquet and all. And we are good with CSV, so that is fine. So our extract and load function is ready. Now we need to create the second function, which will be for transform and load. And this function will be like a little bit complex, because just think about it. You here, first of all, you extracted the data. Whenever we extract the data, we do not perform anything. We simply fetch the data using our client, and that's it. But when we want to transform our data, we need to do a lot more things, right? So here, instead of just creating the direct function to transform the data, we would first need to create the function to provide the context. Why? Because see, in the SQL, in case of SQL, when we were just required to generate the code to transform it, like transform our data, what we did, we simply provided some kind of context that, hey, this is my data, this is the schema, this is the metadata, and please generate the code for us. Similarly, here as well, here the requirement is the data is, let's say, extracted here, right? We want to transform it, so we do not want like anything. We do not want any kind of hard code, you can say Python or Pandas code. We want our LLM or our agent to generate the code for us. Simple. So here what we will do, we will simply say, hey LLM, let's say this is the LLM, or let's say our agent. Okay, So here we will simply say, hey, you need to generate the pandas code, but before generating it, because you do not have any context of our file, here are, let's say, top 5 or let's say top 3 records, because that way LLM would have some kind of context, and this time whenever your LLM will try to generate any code, let's say for example pandas code or any code, right? It can be PySpark code as well. This time LLM can create or you can say generate the exact code. Why? Because it will have some context, like how your data looks like, all of the schema, all of the columns, everything, literally everything for that particular file only, because we are just talking about that file. Cool. So here we will create one utility function called, let's say, transform load context, because this is not load, this is just the context. So after context, then we will just create the tool for, let's say, transform and loading. Simple. Okay. So here I would need first of all self. Second thing, I would need the location, like where my file resides. So I'll simply say file path string. And just to tell you this thing, so whenever you want to transform any data, and this is like again according to my personal experience, we should always provide the absolute path, like where our file resides, instead of handling the, you can say, root directory or whatever. Because the thing is, currently we are using our on-prem to load the data, but in the real world, or let's say, or even in the real world, we just save the data in the on-prem as well. But I'm just telling you some edge cases where you would be storing the data in the data lake. So always try to write this particular function in such a way that you are providing the exact path and you are not doing any kind of root directory and all within this function. It's a good practice. Okay, we can do it in case of extract, that is fine. If you are just simply extracting the data, again, if you are extracting the data and loading it to cloud, then yes, you should just pass the absolute path. Okay, just personal experience, some people like prefer writing everything within the function as well, not a big deal, but I'm just simply giving you some suggestions. Okay, file path, that means wherever the file like should be where the file resides, and then output folder where I want to load this transform data, and then obviously format. These are some things that I would need, and obviously I would need to pass some, you can say, context. So this tool transforms the data, and perfect. Here I can just rely on this suggestion, and I think this is good. So this is, you can say, context that I just want to provide, and let's say returns. Perfect. So this is the context to my tool, right? So first of all, how I would need to transform the data, that is the big deal, obviously. So first thing first, I would need to read the data. Okay, I would need to read the data. How I can just read the data? I will simply say pd.read and whatever I want to do. But the thing is, if you have some understanding about pandas, let's say I just want to read any pandas file, I will simply say read CSV. If I want to read JSON, I will say JSON, right? So I do not know what is my file extension. I do not know. But you will say, Ansh Lamba, you are asking for it. No, this is like output format. This is not input format. Oh, so we would need to fetch it automatically. Cool. Okay. How we can simply fetch it? It's very simple. Let's say file extension, and then simply get your file path, os.path.split text, which is the function within the os.path. And then we can simply say, we just want to fetch the last, or you can say when you just split, it will just split in 2 parts. So to simply split it like this, let's say you have the file like this, extract.csv. So if we just split it, it will become like this, a kind of list where it has extract and then it has .csv. Yeah, .csv. Cool. So we are simply trying to fetch the .csv, and that's it. I hope it makes sense. Okay, cool. Very good. So we are simply splitting the text. Okay. So now we will simply say we have the CSV. So I'll simply say if file extension equals to .csv, then we just want to do this elif this one. And if we have Parquet, then simply go with Parquet. If we do not have any kind of file format other than this, simply say unsupported file format according to our agent. But if you just want to add more and more capabilities to your agent, you can add more and more file formats. I hope it makes sense, right? Second thing that we just need to do is simply read the top 3 records. How you can just do it? Simple. Head function. Simple. Let's say top 3 rows df.head3. Here you would need to just add one thing. which is string. Why? Because we will be simply adding this thing as a context, so we do not need to pass a data frame object. We just want to pass, let's say, string format of it. I hope it makes sense. And we'll simply say return top 3 records, or let's say top 3 rows, just top 3 rows. We do not want to, let's say, do anything special, simply string version of it. So this is also done. That means we have the context, our agent will have the context, right? Cool. So now if I just go back to my architecture, so this is my architecture. So now what will happen? This LLM will simply go to, let's say, the source. Okay, it will have the context and everything is fine. But now the thing is, this LLM will obviously generate some code for you, right? Let's say this LLM will generate this code for you. Make sense? Any code. Okay, any code. Now when we have that code, and let's say for our example we are generating the pandas code, right? How we can actually run this code? Think about it. LLM can generate the code. LLM cannot run the code. It does not have any kind of runtime. It does not have any kind of runtime. It does not have any kind of sandbox. Good point. Like obviously we can just attach a sandbox. It's not a big deal, but usually we do not do it. We want to run the code on the server side. Okay, if we want to, like we can obviously offload this task. We can just attach a kind of Python runtime. We can just let's say rent one sandbox, and we can just simply provide, hey, run this code and give us the results. But usually we do not perform this thing. We simply create a kind of task within our server, and we can offload this task to, let's say, queues and all those things. But for now we are not talking about queues and tasks. We simply want to run this code on our server. Simple. Very good. Because whenever you just run the code, run anything like Python thing, obviously it is a kind of process. Whenever you run Python code, it is a process, right? So you can simply create tasks and queues using RabbitMQ and all those features to offload that work if you want to run on the server. Now some teams also prefer like creating a kind of, you can say, cloud runtime, or let's say Python sandbox, where you simply send the code. Let's say this code is generated here. Let's say our LLM generated the code. So here we can simply send this code to, let's say, this particular sandbox, and sandbox will simply run it and it will give us the results, whatever the results we have. It is possible. We can just do this thing, but we do not want to just attach a sandbox because we want to run our code within our server. This is our requirement. Okay. And whenever you just run the things on a server, then what you should do, and I'm just talking about the production scenario, then you can create something called as background tasks. Oh, here you can just create the background tasks, and when you will be creating these background tasks, then you can simply use queue to simply put them in a obviously order to run this function, run this function, run this function, and blah blah blah. Okay, but here the good thing is you do not need to perform anything because we are using our own server, so we are good. Cool. But I'm just sharing this thing just for your knowledge. Okay, so now let's create one function to execute our Python code. Okay, let's say execute code, or let's say execute Python. This will become self, and this just needs code, and that's it. Nothing fancy. Now the thing is, in order to run Python code, there are multiple ways. One thing is we can use Docker. We can simply create one, you can say, virtual environment, or basically your isolated environment, run the code in Docker, and that's it. Second thing is you can use sub process to run the Python code within this particular function. Third thing, and the most simplest and the most lightweight version that we have, is using exec function. Okay, what exec function do? Let me first of all try to write my context, because this is very important. Perfect. So here I'll simply write the exec. Now exec function is obviously a built-in function, and here we do not need to do anything else. Simply hand over the code and that's it. Really, literally. Okay, so simply say try and exec, and then your code, and return code executed successfully, except failed to execute code, and E, whatever we have. Simple. This will simply execute the code. Yeah. And obviously internally it will simply run the code within the same process. It will not create a separate independent process. That is why it is used to quickly run that particular small code, where you do not need to, let's say, allocate dedicated memory to anything, or any stuff. Okay, so we simply want to execute this code. Now this will execute our code. Okay, should we test it? Obviously, first of all, we should test this function transform load. We cannot test this function execute code because this will be running directly from the LLM. Okay, but we can, yes, genuinely test this function. So let's try to run this function, and how we can just run it, let me show you. So we already have this data here, right? And let me just copy the absolute path, and I will say print obj dot transform load context, and here I can define the path, which is this one. And if you are on Windows, you can also use backslash because it works well with backslash, double backslash basically. Cool. Even if you are on let's say Mac, then obviously it's not a problem. Then I have simply provided the path, and I would need to provide, okay, this is my output path, which is the transform folder, looks good, and CSV. Okay, I don't need CSV here, actually no, because we are simply providing the context, so I do not need to do anything else. Transform load, and I do not even need the output folder because we are not writing the data here. This is just the context. We just need file path, and that's it. Cool. We can just remove these two things, and that is it. Okay, so now let's try to see if we are able to get the top 3 rows or not. Yes, I am able to get it. See, perfect. So that means this function is also working fine. Absolutely amazing. Okay, so this function is also good. Now we are good to directly jump on to our agent, which is ETL Analyst. Now the good thing is, to all those Claude model lovers, so let me just open my .env file, and here I have simply added my Anthropic API key as well, because for React agent, it is my personal experience that Anthropic or basically Claude models are way better than any other thing, because it runs that particular agentic loop very nicely. And again, personal experience, not a choice and not a, you can say, suggestion. You can just use OpenAI models as well, but if you're using OpenAI models for this particular thing, you would need to make one change here like this. So as you know that we have these 3 models, you would need to add this particular thing, which is model quarks reasoning effort equals to none, because by default in the latest OpenAI models, they have by default turned it on, basically the reasoning effort, and we do not want to make it on whenever we are running the tool calls with the LLM. What are tool calls? Obviously you will just learn right now, but you just need to make it off. Just make sure it is off, and you can just simply add it like this, model quarks, and turn off. Again, it was not there in the previous models, it was working fine, but now in the latest model like so 5.6, Sol, Terra, Luna, they have this thing. Okay, and for my Claude model, I'm simply creating one more elif, level dot lower equals to Claude. So if it is Claude, then I want to use chat Anthropic, and the model the first thing is temperature is not supported here. I would need to use Claude Sonnet 5, which is a good model, especially for agentic loops. Okay, and else we do not want to worry about anything. Simple. Okay, very good. So my LLM pick is also ready. Now I can just simply go to ETL Analyst. Now, as you know, the first thing is we just need to create the model class, basically our agent class. But even before that, we would need to load that particular, you can say, models directly within our file. So let me just add that boilerplate code here, which is doing nothing but just the same thing. And here I have simply imported the ETL agent schema, AI message, and blah blah, and obviously ETL tools class that we have just created in the utils, and that's it. Nothing fancy, same boilerplate code, same. Okay, so now let's create our agent. So this is our ETL agent. Perfect. So first of all, let's create a class. Let's call it as ETL agent. No, let's not create the class. Let's directly create the functions. So first of all, we will need to create functions. We already have functions on Lamba. Why do we need to create functions? These functions are special. These functions are not your regular functions. These are tools. So let's say I want to create a tool called extract load tool. Okay, and what it will do? Nothing. It will call this function, this one, extract load. So I just need URL, output folder, and format, these 3 things. Okay, I will need URL string, output folder, and string, and obviously I would just need to provide the context, same context. Okay, Then ETL tools, I have just created the object and then call the function, and that's it. Literally that's it. Nothing fancy. Okay, cool. So this is a tool now, yes, but this is a function. Why are you just calling it as a tool? You convert this thing into a tool. How? Because if you would see, I have imported this special module from Langchain.tools import tool. When I use this decorator here, this will become a tool. Oh really? Yes. Now this is converted into tool. That is so easy to convert a function into a tool using Langchain tools. So easy. Simple. Simply write anything in your Python function and convert it into a tool like this using a decorator. Wow. Yes. Wow. So first tool is created. Very good. And in this tool, we are actually doing nothing fancy and there is no LLM required here as well. So it's like one of the simplest ones. Second one is complex, but let's perform the complex thing as well. So this complex is nothing but your transform load. So let's say df transform load, not context. This is a tool itself. And here I would need obviously file path, right? And here I can define, we will decide like what we are returning. And here I will need one thing as well, like output folder, perfect, and output format as well. I would need these things. So this is my context, and here we do not need to directly return this thing because once we have this ETL tools, this ETL tool will not do anything else. Obviously. And first of all, this file path is your input file path. So let me just make it more readable. This is input file path, like the file we want to transform. Simple. Cool. Now when I will be just calling this function, which is your, let's say, top 3 rows, or you can say context as well, I will simply say ETL tools.transform load context, obviously. And here I would need to pass input file path, output folder, and output format. Obviously, agree with me? Very good. So I have these 3 rows as my context. Now I need to provide this context to LLM. Agree? So let's try to create the LLM. So first of all, I will simply say LLM equals pick LLM, and I want to pick Claude. So this is my LLM, right? Now, whenever I want to just pass anything, I first need to create the prompt. Agree? So here comes your detail prompt again, and you can just make it more and more, or you can say better and better according to your test, according to your personal experience. But here I do not need to just write every single thing word by word. I can simply copy and paste the prompt. I simply created it like this, and I was just testing this out, and this was working fine. So I just need to perform this thing. And here I would need to just copy that. Let me just do it for you. So let's say prompt. Perfect. So this is my prompt, which is doing what? Simply telling that you are a Python data analyst and create the Python data frame pandas from the data stored in this file path. This is your input file path. Let me just make that change, input file path. And this is the user question, because obviously we need to provide the user question as well here, that what exactly we want to do in the form of, you can say, transformations, right? It can be like anything. So this is my now user question. Oh, so we just need to call it from here on the top. User question. Perfect. So this is my user question now. Okay, makes sense. Okay, so we have this input file path, we have here Claude, we have everything else. Perfect. So this is now my complete prompt that I just want to pass. Simple. Very good. Now once we have this prompt, I would need to send this thing to my LLM, obviously, just to generate the code. So you can simply say response equals llm.invoke, and invoke is what? This prompt. Simple. And as we know, like whenever you just get the response, we get the response in the form of your content, obviously. So we can just fetch the content as well. And do you know what? This alone is not enough. Why? If you have used, let's say, ChatGPT to generate the code, sometimes it can just generate the code like this. Let's say Python, and then it just writes a code. If you have just observed that thing. So it is not the default behavior every time, but sometimes if model is just if we are just using some lightweight model, it can throw these kinds of silly mistakes. And whenever we are generating the code, obviously I cannot run this code in my Python console. See, can I run this code? Like obviously here I have, let's say, Python code, but because I have this thing, I have to strip it out. I have to clean it out. So this is, you can say, a kind of optional cleaning that you can just perform. Okay. So this is my, let's say, pandas code, and here is my response. I hope it makes sense. I'm simply stripping it out, all the white spaces, all these backticks, and any kind of Python if it is written. Nothing. I do not need anything like this. I hope it makes sense. Okay. Once I have this thing, this pandas code, then I can just generate the code. Okay. So I can say execute the pandas code, and then I can say, let's say, results and ETL tools.execute code if the function name is code, or execute pandas. Let me just check execute code. Yeah, perfect. Execute code, and here I can just hand over the pandas code. Now what it should do, it should just give me the response like this, return. Perfect. And I can say return results. Now whenever this will return me the results, I should simply say that data is transformed and saved, and this was the code used. Why? Because see, if I just go here, it will simply say code executed successfully. It will not say anything that data is transformed, data is this, data is that. And this way agent will not know whether my work is done or not. So I need to inform my agent as well, right? So I can simply say return the data is transformed and saved at output folder, and that's it. And then I can say pandas code executed. Okay, it is a good thing. I should also see what code it has executed, and execution result, which should be this one, a code executed successfully. I hope it makes sense. So this is the thing I want to return. These are my two tools that I just want to create. I hope it makes sense. Cool. So I just need to create my tools list. So these are two of my tools. You can also call it as toolkit, where you simply assemble or combine all of the tools. Okay. Now the next thing, according to our architecture, we need to hand over these tools to our LLM, right? See, this is the LLM. These are the tools, and we need to hand over these tools to our LLM. So here comes the special function called bind. Okay. Here we simply write LLM bind equals LLM dot bind, or let's say bind tools, and then hand over the tools. Here we have not created the LLM object right now. We can, obviously, because here we are using the LLM object within the function, right? And here I can create one LLM object outside as well. And I just want to use Claude because I know Claude is like a better function, better LLM for my agentic loop. Okay. So everything is done. Really, yeah, everything is done. Now we need to do what? We need to start creating our, you can say, agent graph. But Ansh, Lamba, we do not need any kind of agent graph. You told us that this is a stateless agent. Yeah, this is a stateless agent, but still you would need to create the node, because see, this is one node. This is nothing but just a node in itself. See, and this LLM is not directly connected to these tools. Like obviously it is connected to these tools, but in order to execute, remember when I was just explaining this loop, I told you that we do not directly, or basically LLM cannot directly run these tools. It can only say that I want to use this tool. But in order to run these tools, we need a dedicated node like this. Oh, okay. Okay. So let's say this will be our tool node. Make sense? This is our tool node. Okay. Now, Ansh, Lamba, just tell us one thing. Yeah. So see, this is how it works. Let me explain you. I know your question. So yeah. So now you will say, Ansh, Lamba, let's say we are talking to this agent. Okay. And this LLM wants to use this tool. Let's say this tool, because we want to extract the data. How LLM would know that it needs to use the tool? How? And if it wants to use the tool, how it will use the tool? Okay, let's talk about that architecture as well. So basically what will happen initially, The graph will look like this, that this is my node, LLM node. Okay. This is, let's say, LLM node. Query will come here. Okay. If it does not want to use any kind of tool, it will simply end the chat. Simply end the chat. Okay. If it does not want to. Okay. This is my end chat. Cool. Cool. If it wants to use this tool call, or basically it wants to make a tool call, it will simply return something called as a kind of output. In the output, this time in the content, we will not see anything. Content will be empty. The content key will be empty. That means LLM will not generate anything. Basically it can, but the main thing is, because it differs from LLM to LLM, the main thing is inside tool calls, we will see the tool names. Oh, because we have binded our tools to this LLM right here. Let me just show you. Right here. Okay, makes sense. So this time this LLM will say, hey, I want to use this tool. Why? Because I feel that I can perform this task using this tool because I have read the description of this task, and according to the question that I have received, I should make this tool call. But it will not make the tool call. It will simply return that I want to make this tool call, and that is it. Then we will use a conditional edge that we have already created in the previous example. Similar thing, we will just do it here as well. We will create a conditional edge to the tool node. If in our output of this LLM, we will see any kind of tool calls, we will simply go to this tool node, and within this tool node, we will make these tool calls 1, 2, 3. Oh, and like whatever tool calls will be there, it can be 1, it can be 2, it can be more than 1, right? It depends like how many tool calls LLM wants to make. If we see that tool call, we will externally call that function. Okay. And whatever the output of that function we will get, we will save that message as a tool message. Oh, and we will append or basically add that message within our messages key, and we will send this information back to the LLM, because see, this is going here. Now LLM will read the information again because this is a loop. If LLM feels that my tool has done the work and I do not want to make any other tool call, it will simply say end the message, like end the chat, end the graph, and that's it. If even after making the tool call, LLM feels that I should make one more tool call, maybe the work is not done yet, then it will simply hand over the information in the form of tool calls. We will make the tool call using conditional edge, and that's it. This loop will keep on going until LLM is satisfied. Oh, this is your React loop. Reasoning and acting. It will reason the output and it will act accordingly. Reason, act, and that's it. Cool. Okay. How we can just build that loop? It is very simple, by the way. First of all, let's create our LLM node. Let's write here agent graph, and here I can say agent tools. Perfect. So here our tool, here is our graph. So first of all, we will be creating our very first node. Let's say LLM node, and state will be of ETL agent schema. Perfect. And messages will be state.messages ETL. I see. Perfect. ETL agent schema. And messages will be state.messages, obviously, because I just want to fetch the entire history, because I need to pass everything, entire chat history. Why? Because it will be a loop, right? Very good. Then I need to get the answer, obviously. So how I can just generate the final answer? Again, I would need a kind of prompt. Let's pass this prompt. In this prompt, the main thing is we are simply saying that you are a Python data analyst and you have access to the tools, and whatever you want to do, you can do it. But we are simply telling that you have the tools. Even if you do not tell it, it has that information. But when you just provide that context, it can think about it. Okay, I can just make the tool calls. Okay. So I can simply copy and paste the prompt again. And yes, it is up to you what type of prompt you want to write, because again, it is just creativity, nothing special. You can write the best prompt in the world. not a surprising thing to me, because obviously like anyone can write prompt and everyone's prompt is like different. So yeah, you can just write any prompt. Simple. The main thing here is whatever messages we are getting here, we simply need to append that thing. So let's say state.messages equals messages.ai message content equals final answer. Make sense? Here one thing is we can write AI message here if it would be only content, but because the final answer, this one, this particular, you can say response that we'll be just getting, let me just write LLM, or let's say this is my prompt, prompt, and then let's say LLM.invoke final answer. Perfect. So here, if I just use content, then it makes sense. I can just perform this thing. If I'm not using dot content here, then I do not need to write AI message because it is already AI message. So I can literally write final message, but yes, I would need to add a list because we always use list with the messages. Cool. And we can simply say return state. This is my LLM node. I hope it makes sense. This was simple. This was simple. The main thing that you need to learn here is how to create a tool node, because tool node is fancy. And you know what? It is not fancy. Like it is a little bit just complex, but it is very simple. First of all, we need to create a tool node with some context. Let's try to create that. So let's say tool node and state is this one. Perfect. And let's try to add some context. This node is responsible, even though it will not use this particular thing like this context, because this is itself a tool node, but within the tool node we should have the context. This node is responsible for invoking perfect. So here, first of all, we need to create the list of all the tools that we have, all of the tools. Like let's say you have 2 tools, 3 tools, 4 tools, whatever. I just need the name of every tool. Okay, so I will say tools by name, and here I can simply create a kind of dictionary. Here I'm doing nothing fancy. Tool.name, then tool for tool in tools. Simple, running a loop and simply getting the name of that tool, because whenever we just use this decorator, this one, this adds the metadata to our tool, and within that metadata, one important key is tool.name that I want. I hope it makes sense. Very good. Second thing that I would need is you can say results. Okay, tools results, and I need to create an empty list because I will save this list, or basically fill this list with the tool messages. Again, simple. Very good. So this is done. This is done. Now I would need to run the, you can say, loop over tool call, because what will happen if I want to make, let's say, any tool call, I can even show you like how this will look like. So let me just do one thing just for your understanding. I'm simply writing one function here, name equals to main, and here I can simply say LLM bind equals to this one. Okay, and then say LLM bind dot invoke, and I can say I want to extract the data from the API endpoint, and this is my endpoint. You can just pass any endpoint. Okay, perfect. If I just want to run this thing, do you know what will happen? Let me just run it. It will not give me any response. It will simply say that I want to make a tool call, and that's it. Let's wait for the response. I can just show you. So let's wait. Perfect, because I didn't write print statement, but it ran fine. That's a good thing. Let me just use print here. Perfect. Because this way you will have some understanding like how does it create that particular response. So perfect. If I just scroll up, I should see content equals to this one, which is text. In Claude models, you will see this thing. In OpenAI models, you will not see this content, but this is optional. The main thing is tool calls. So let me just find that tool call if it has returned that particular thing. Yeah, tool calls. So tool calls is this one. So it wants to make a tool call with extract load tool. And these are the arguments it wants to use. how it generated the right arguments, because LLM is reading my context of my tool that I want to pass these arguments. This is the power of writing the exact context that is required. Make sense? Very good. So this is the information I got, right? With all of the things. This dictionary is the main thing. And with the tool ID as well, obviously. And this is a tool call. I can just write this thing here. So this will be my response, which is the major thing that supports my React loop. I hope it makes sense. I can simply save it here. Perfect. You can just keep it as your notes. Okay. So this is your tool call. This is the response that I am just simply getting. So let's keep it here. This is the response. I hope now you would understand like how is it like working. Okay. So now I just need to run the loop over this tool calls, because currently I just have one tool call, but I can have multiple. So I have to just run a loop. So let's try to create that thing. Perfect. So here, let's get back to our function. So here we just need to say for tool call in tools, or let's say tool calls. Yeah, we can also find the tool calls as well. Not a big deal. But the main thing is, where is tool calls? Where is tool calls? We do not have any kind of tool calls, but I can fetch it. Let's say tool calls equals state.messages -1. That's it. And within that, I know that I have this key tool calls. I hope it makes sense. Obviously, these are the tool calls, right? These are the tool calls. I can simply fetch it. Cool. Now I would need to get the tool one by one. How? It's very simple. So tool equals, and I would need to run the tools by name thing that I just created, this one, tools by name, and then within that I have tool call, right? Tool call, and then within that I have name. Simple. Simply fetching the tool name from that tools by name. Okay. Now I have the observation. You can also say reasoning, anything. How? I need to invoke this tool. Got it? Okay. Tool.invoke, but how? I would need to pass the arguments. So tool call and then arguments. This one. Simple. Oh, because see, within my tool call, I just showed to you, within my tool call, I have the arguments, right? See, within the tool calls, I have the arguments. Simple. So I just ran a loop over this particular element of my loop. So this is my first element. Let's say this is I, for I in loop. So this will become I of arguments, right? That's exactly what I'm doing. I of arguments. So I'm simply saying, hey, this of arguments, and that's it. Because I do not want to just hard code each and every value. It will simply take it from my arguments. That's it. Whatever observation I have, I will simply say tools result dot append, but not exactly or directly. I will simply use tool message. Why? Because obviously we need to tell AI that, hey, this was a tool message. Okay. Content equals to observation, and then tool ID, because I will be just using tool ID. You can also use tool name as well. I think it should work, because LLM just wants to know like which tool call was made, but it is like good thing if we just use the tool call. Okay. So let's say tool call ID equals tool call of ID, because we have ID here. Where it is here. See, simple. I hope it makes sense, because this was like the most simplest explanation that you would get. Simple. Very good. Now, once we have all of the things available, we can append this particular state, which is this one, tools result, into our main list. Okay. After coming out of this loop, because we can have multiple tool calls. So let's say state.messages plus tool results, simple, and return state. Cool. So this is also done. I hope it makes sense. So this tool call is also done. Now we need to do what? We need to simply create the nodes and edges, and that's it. So let's try to create it. And obviously I know that I didn't just test these tools, but do not worry, we'll just test it whenever we will be just testing the agent. It's not a big deal. So now let's say agent nodes and edges, or let's write here nodes and edges. Cool. So first of all, we'll be simply creating the graph first of all, right? So let's say ETL Analyst graph equals not state graph. We would first, yeah, we have state graph, and then we have ETL agent schema. Perfect. So we have this graph ready. Then we can simply add the nodes same way we have added nodes back in our previous example. Okay. So add node. This is my first node, which is LLM node, and this is my graph function. Simple. And then add node, one more tool node. So this is done. Now here comes the edge. We know that we have the edges. So ETL Analyst dot add edge. The very first is start, then LLM node. This is fine. This is easy. But now we would need to create the conditional edge the same way we created in case of SQL as well, right? When we had like, let's say, multiple conditions. So how we can just simply perform that thing? It's very simple. If we have any information, or basically if we have any tool call, then we simply need to go to tool node. Otherwise, simply go to end. Make sense? So let's create it. So let's say def is tool call, and we would just need to get the state like this, and we can say tool calls equals state.messages.tool calls. If tool calls, return tool node, else return end. Perfect. This is my function that I just want to use. Now I can simply create an edge using this conditional function. Cool. So ETL Analyst graph dot add conditional edges. Perfect. And here I will simply say I want to connect LLM node with my conditions, and condition will be this one. Mapping is tool call, which is tool node. I can simply add here as well. So let's say is tool call, and then I want to define the dictionary. So dictionary will say tool node will become tool node because I have the tool node here. And if I have end, then it will simply go to end the loop, and that's it. Make sense? And then I would need to add one more edge, which is going back to the LLM, because currently, if you just look at the architecture, we are also going back to the LLM. Cool. Very good. So let's say ETL Analyst dot add edge tool node to LLM node. Simple. Very good. So this is our graph that we just wanted to create. Now, obviously, we can just simply create the, you can say, image optionally. So let me just write that again, same boilerplate code for you that you do not want to write. Okay, but I can just write it for you. Don't worry. Perfect. So performing IPython and blah, blah, blah. Let's try to run this particular code and let's see what do we get in our graph. Obviously, everything is fine. Yes, I have got the graph, and perfect. I can see that it is running one React loop, which is exactly same as our architecture, as you can see here as well. See, tool node, and obviously we have tools, and then it has this end and then this React loop. Wow. One thing for you, and I think you will be able to answer this thing now. Why I'm seeing dotted line here and why I'm seeing black line here? Why? Because this dotted line is conditional. It can go to tool node and it can also go to end, but once it is reached to the tool node, it has to go back. It cannot directly end the loop directly from the tool node. That will be a wrong execution, because tool node will return something useful for the LLM. So whatever the message we are receiving back from the tool, we have to send it to the LLM back. That is why it is not conditional, it is mandatory edge. Okay, very important question. So that means our graph is just like looking like a wow. Okay, so now we can actually test it, and obviously I have also not tested it. So let's try to test it together. And how we gonna test it? We will simply delete this data. Okay, and I can create one empty folder for transform as well here. Why I'm creating it? Because I'm not creating it within the function. So I just want to create it beforehand. Let's say transform, or let's keep the t small. Cool. So now we will just perform this testing one by one. First of all, we will just ask it to extract the data. Then we will just ask it to transform the data, and let's see how does it perform. So let's try to test it. Our Python data agent, ETL Analyst agent, not Python data agent. So now let's try to write something. Let's say we want to simply say response equals ETL Analyst dot invoke, and we want to invoke it with, let's say, ETL agent, not ETL agent schema, because we have, I think, human message. I think so, because let me just check the schema. Yeah, we just have messages, so we do not need to pass anything else. We have to just pass everything within our messages key, everything. So let's try to pass it like a kind of dictionary. So let's say messages, and then you can simply write human message. It should be good. Content equals to whom. So let's try to write it. I want to extract the data from the API endpoint, and let's provide the API endpoint. What was the API endpoint that we used? Let's say this one. You can just use any endpoint, obviously, but I just want to make sure like it is working fine. So this is my endpoint, and I also want to tell it that what exactly I want to do. Then I can say that, hey, I want to extract data from this and save it to data/extract folder in the CSV format, right? That's, I think, enough, and that I can just expect from any business stakeholder. And I think that is enough, because we just need to pass the messages key and that's it. So what it is saying, I need to just do this print and let's say response. Perfect. So now let's try to run it. Let's see what do we get. I think we have ETL Analyst, right? Yeah, we have ETL Analyst. Cool. So this is running my agent. Okay, let's wait. Invoke of LangGraph. Okay. And do we have the data? No. Oh, bound method pregel invoke of LangGraph. How did we just invoke it? ETL Analyst dot invoke. Okay, so we have this list. That is also fine. It is saying that we didn't invoke it rightly. Really? Let me just do this. Yeah. Let's do this. It should not make a big difference, but still, some bugs are like subject to these kinds of silly things. Let's wait. Oh yeah, see. Oh, come on. So we have this thing, and I can just see the response and content data successfully extracted. Okay, let me just check. Okay, oh yeah, so this is done, and all of this data is loaded successfully. That means it is working fine. Now the main thing is I want to test the transform data. So let me just try to write that thing. So I have created that particular response just to save some time. So this is the prompt that I have just created in order to invoke this particular thing. And what I'm doing, nothing. I want to transform the data stored in, let's say, data, and I was just testing it out. So it was working fine. And now we have a different folder. So it is called transform, or no, extract. And it is not pokemon.csv file. It is extracted data.csv. And I want to, let's say, put it inside this folder. Okay. I hope it makes sense. Yeah, we are not doing anything. Okay, I think it should work. Let's try to see, because I think I tested it just now, just this particular prompt. Okay, but we do not know the behavior of agentic loop. Sometimes it can just run infinite loops as well. Oh, really? Yeah, sometimes. That's why I just stick to the Claude agents. They are really good. These models are really good. Okay, so let's see if we are also getting the transform data, because I can see it. Perfect. I have got the transformation. Now you will see what transformation did you apply. See, in front of your eyes. I simply said that I just want to see the Bulbasaur, because that is my favorite. Not really. My favorite one was Charmander, but yeah, Bulbasaur is also cute. So I simply type that I just want to transform my file, and I just want to get the Bulbasaur as my Pokemon. So, in short, I simply applied a filter on my data, and I can see that transform data is actually able to perform that thing so nicely. Wow. So this agent is also working absolutely amazing, and I'm really happy with that. So that means our Python agent is also completed, and I can see that, oh, basically ETL agent is also completed. Now what we need to do, Now we need to simply create one parent agent that will do what? Let me just show you. Because now it's time to actually celebrate, because 90% of the things are done. Now we just need to do the 10% of the things. So this will be our data agent. Okay, this will be our data agent, and within this data agent, and this will be a kind of you can say parent. Okay, parent. Within that, I will be having one decider node, or you can say one router node. Okay, one router node. And what this router node will do, router node will decide that whether any query which is being asked by these high technical people, business stakeholders like this, whether this query should be tackled by our SQL analyst or our Python analyst, or basically ETL analyst, because that depends on the nature of the question. Makes sense, right? So it depends, because we cannot directly route everything to maybe SQL analyst, because we need to make it autonomous. We need to make it fully autonomous, that you will simply send the query and our data agent will obviously try to decide it using this router node, and it will automatically send this information to either SQL analyst and ETL analyst, basically depending on the nature. So this is the working that is left. We need to create one data agent, the parent agent. Then we will simply create the very first node within that, which is router node. And you have already seen how to create this, really. Yeah, because this is nothing but more of like creating a kind of decider node. And we already created this node where we decided like whether we should go here or here, a kind of is SQL node, if you remember. Similar thing, we just need to do it here as well. So we'll simply create that particular decider similar to is save SQL, and this will simply decide like whether it should go to this agent or to this agent. And if it needs to go to this agent, simply call this analyst or this analyst according to the right you can say your arguments. So that will be a good thing. Okay, so let's try to achieve this thing step by step. Let's see. So now let's try to create let's try to create the parent agent. So very first thing, we would need a model, basically schema. Okay, so let's try to create the schema in our schema, and this will become judge schema. Do you know what? I can literally use the same schema, but I will just simply create a new one. Let's try to call it as decide schema, or let's say router schema. Cool. Let's say base model. And here I do not need to provide anything. Okay, I can put same answer, let's say of literal type, but the values will not be yes, no. It will be either SQL or Python or ETL, basically. Indicates whether the user's question is related to SQL or ETL operations. Very good. Yes, that's what I want. And obviously the comments. Perfect. So this is my router schema. Now what I will do, I will simply create one parent agent, and let me just delete this crash.py because it is not required anymore. Let's try to create it as, let's say, data agent. Okay, cool. And let me just bring that boilerplate stuff here. This thing. Cool. Data agent, and perfect. So now what I want to do, I first of all need to create the LLM. Now, because here I do not need to run any React or anything, I simply need to decide. So I can literally go with OpenAI models, but if you just want to go with Claude, you can go with Claude as well. So let's use Claude because I just created one new API key. So let's use Claude. Okay, but you can just use OpenAI as well. So here what I will do, I will simply say LLM dot with structured output. Cool. And here obviously I would just need to pass the schema, and here the schema will be router schema, and let me just import it from here, router schema. Cool. Very good. So this is my router schema. Now if I just try to ask anything with LLM, let me just say LLM router, If I just try to ask anything with this particular or from this particular LLM, it should just generate only output related to the literal values I have provided. Let's test. Let's say print LLM router dot invoke. I want to extract data from an API and want to save it as a CSV. Simple. I want to perform this thing. Okay, let's see what do we get. Ideally, I should get ETL in return. Okay, ideally, if this is working fine. If not, then obviously something is wrong and we would need to fix it. Let's see. Answer equals to ETL. Perfect. Comments equals to user. And this is working fine. So I will be using this LLM router. Cool. Very good. Now let's try to create our graph, data agent graph, which is very simple. First of all, we need to have one node, which is our decider node. If I just go to the architecture, so I would need one router node. This will go here and then router node. Yeah, just router node. So let's try to create df router node, and here it will be having state. Have we created any state? No. So we should have at least one state. Yes, obviously for this particular graph. So let's try to create one schema, and let's try to create one class as data agent schema. And we do not need actually anything. We just need messages, and I do not even need messages here. Or do I need messages? Yeah, let's keep messages because I would need messages. That is fine. Okay, cool. So let's try to first of all close all the tabs which are not required. Perfect. So here I'll simply say data agent schema. Perfect. So data agent schema is here, and what I need to do, I would need to fetch the message equals state dot messages, and here I will simply get only -1 because I just want the last message. Last message is my human message, right? I can also say dot content if I want to, but if we are simply fetching it as -1, it is also fine. It's not a big deal. Okay, cool. So this is my message. Now what I need to do is let's provide content here. Yeah, let's use content. And once we have this message, then we need to simply send this thing to our LLM router like this. So let's say route response equals LLM router dot invoke message. That's it. Here I cannot use dot content because if you would remember, if I just go to SQL Analyst, when we were just using is SQL and blah blah blah, let me just search that thing. Is SQL. Perfect. Here we have to use this dot model dump because remember this is a Pydantic object. So if you just want to fetch it, we have to just use dot model dump like this. Now it will be just be a dictionary. Route response dictionary. Cool. Very good. So now that means we will be having that particular thing, right? And I think I should just perform one more thing, which is my schema itself, because if you would see currently our schema doesn't have any key which will hold any kind of flag. So I can simply say route response. Okay, and here I can have string because we do not need anything. Perfect. Route response because we will just update this thing as well, right? So let's say we have this thing, so I just want the route response dictionary and I want just the answer, right? I just want this answer key. I'll simply say state dot route response equals route response dictionary, not dictionary like this, because let's say route response equals to answer. It makes more sense. Okay, so now it is my response. So this is my first node. That means it will simply say either we need to go to ETL side or SQL side. Now this is the only node that we have. But now we know, now we need two more nodes, right? One is for my SQL node, the second one is for my ETL node that I just want to run, obviously. So let's try to create that as well. So this will become my SQL node. Let's try to run, or let's try to create first of all ETL node. So this is my ETL node, and here actually I do not need to use any state, but still we can just simply keep it because we would need to append the messages and that's it. So here my message is this one that I would need, which is your content. That makes sense. So I have this message. Now how I am calling this function, let's say I have just got to know that I just need to run my ETL agent and that's it. Cool, very good. How I can run this agent? How? How? In order to run this agent, I would need to pass only this thing like this. So I would need to invoke my agent like this. Oh yes, I would need to invoke my agent like this. Okay, and for that I would need to basically import ETL Analyst. Yes, obviously, because think about it, how I would just call this agent. Let's say forget about this def. Let's say I will write pass. Let's say if I just create one simple function for you, if underscore name equals to main, I want to run, let's say, this agent from this file. How I can just do this thing? Let's say this thing, I want to run this thing like this, right? So how I can import this thing? So in order to import this ETL Analyst, I would need to say from ETL Analyst import ETL Analyst. Makes sense like this, because see, within this ETL Analyst I have this ETL Analyst. Oh, makes sense. And just for you, I can even put this thing here out of this particular main thing because I would need this compiled version of ETL Analyst. Makes sense, right? So can I just compile this function now? It should work. Obviously it should work. If I just run this thing now, everything is fine. If I just, let's say, call this function from here, it should work. Let's see. And if it works from here, then it should work from inside the function as well. Make sense? And here we do not need to call this or basically import this file directly from the root because this file resides directly within the same folder. So we can directly do from ETL Analyst, import ETL Analyst. But if you just want to import it directly from the root folder, it should also work, and that's it. So I think it worked. And if I just go to, let's say, transformed data, I should see this data. Obviously, yeah. So I think it should work. Cool. Okay, makes sense. So that means I can just write it here. So in order to call this function, I would need to do just this thing. Just this thing. Let's say response. And perfect, like this. Now, the only thing that I would just need to make is I need to pass the message instead of hard coding anything here, because this thing will be coming directly from a message. Make sense? So here I will simply say a message. Let's say perfect. Oh, so this will call my function. Obviously, that's what I want to do. That's it. Right? Okay. Make sense? Okay. That's it, because here we do not need to do anything else. We have the agent, we just want to run it, and that's it. But yes, once we have the response, we need to simply append it. That, hey, this was the message. Hey, this was the thing. Okay. And here, if you would just see that in the response itself, we get literally everything. Yes, like we get all of the things. If you will just see here, obviously we do not have the output, but you would have seen like we get everything, like human message, AI message, literally everything, right? So here we can append the useful information within our messages as well if we want to maintain the chat history. Cool. So here I'll simply say state messages equals state.messages plus list of response. Cool. Very good. And it is optional, by the way, because obviously when you just want to store the messages, you just do it with more cleaner way, and you can even store this particular thing in the database just to persist it. But let's say we do not want to persist it in the database for now, we just want to keep it in the memory. Similar to this, we will simply create the SQL node. Perfect. And here we will fetch the content. But here, if you will just look at the SQL Analyst, the invocation is not very simple. Obviously, because here we have to pass the entire state. See, here we have so many things. Makes sense. So I will simply say input schema. And we need to pass this entire thing, the input schema. And then we need to invoke it. Okay. So response equals SQL Analyst dot invoke input schema, and obviously we need to add that SQL Analyst as well. So let's say SQL Analyst is here. Perfect. And what we need to change, we just need to change this thing, right? Here it will become my message. Cool. And we do not need to perform anything else, because everything else will be automatically added, automatically you can say extracted in our agent itself, and we just have this particular response. Simple. I hope it makes sense, right? Good. And now I can simply say state.messages, add this response, and that's it. Okay, so these are my nodes. Now I will simply try to create my graph. So let's say data agent equals to state graph and then data agent schema. Perfect. And we can obviously compile the same stuff, the same boilerplate code to compile it, then to see it, and we can also see this thing as well. Perfect. And this will become my data agent. Data agent, and this will become data agent my graph, and cool. So now let's try to run this thing. Let's see how our image looks like for this data agent. Do we have any image? No. Did you mean ETL Analyst? Cannot import SQL Analyst from ETL Analyst, obviously, because we have to import it from SQL Analyst, not from ETL Analyst. From SQL Analyst, import SQL Analyst. Perfect. Now let's wait. Let's see what do we get. Okay, none type object has no attribute cursor. Again, my database is turned off. That is why it is throwing that error. Let me just turn it on in just a few minutes, and then we can just check. Because obviously it just needs to make sure like it is able to perform all those things, because whenever you just create the object, it simply creates the client with that database. Okay, see, it is not running and blah blah blah. And let me just try to turn it on right now. So I have turned on my SQL server, and now let's try to run it again. Let's see. Cannot import SQL Analyst from SQL Analyst. Oh really? Do we have a different name? No, we have different. Oh, okay, so that means it is also within my if underscore name. So let me just make it outside. Wow, perfect. So now let's run it. Graph must have an entry point. Obviously, Ansh, Lamba, we have not even decided the starting and end nodes and all. Okay, so let's do it. So we have the state graph. Now let's simply say data agent graph dot add node. Yeah, router node is good. Yeah, router node and router node. And after that we have data agent ETL node, then SQL node. Then we need to add edges. Dot add edge. Perfect. Now we need to add a conditional edge. So I'll simply say def router edge state is this one. Perfect. Is equals to equal and ETL. Yeah, that's it. So here we can just simply define the nodes like this. Perfect. And now let's try to run this particular code again, because now we have nodes and edges as well. Is it fine now? Yes. Data agent graph, and I can see that thing. Router node, ETL node, SQL node, and end. that means this graph is absolutely amazing. So that means it is compiled nicely. It is built nicely. Now, obviously we need to test it. So let's try to now test our agent. And if it runs fine, then obviously this is done. This is good. Now let's test it. Now let's try to test our agent finally. And I have just made like one change, not change, just added one thing. I have just returned the state as well because we just forgot to return the state in all of the nodes. So let's try to test it. Okay, and just to test it, I have literally deleted all the files from my extract and Lamba, where is your mic? So basically, now let's try to test our model or basically agent. And I was saying that I have added only one thing, which is your return state. Okay, simple. And I have also deleted all the files from extract and transform folders, as you can see, so that I can just see the new files, obviously, right? So now let's try to test it. I am really excited to test it. So first of all, let's say data agent, or let's say response equals data agent dot invoke, right? And within that I have just messages. Content is this one, and I can literally pass any content, right? And let's try to test our SQL model. First of all, you can just test anything, but let's say I just want to test my SQL model first, and I don't want to extract it. Okay, I want to test my SQL model. So I can literally run any query, and just to make it quick, I can just use this particular query that you were just using before. So let's try to copy this, and actually you can just ask anything of your choice. Cool. So now let's say print response. Perfect. And now let me just run this agent. So now what it will do, it will automatically divert this query to the right agent, and agent will just run the agentic graph within that agent, and it will return the response back to me. Wow. Before task with name router node, what is this thing? Input message, human message. Okay. Response. Okay. What is this thing? What is this thing? Human message is this one. Okay. So I have human message. That is fine. And it is saying router node. So something is broken at the router node, and it is related to the Pydantic schema. So nothing is wrong with our agent yet, but something is wrong with the agent schema. What is wrong? I have simply provided messages. Oh, I see. Because in the schema, I have one more key, which is route response. Makes sense. And that is the power of Pydantic. It throws the error right away, and I like it. So route response will be your empty because we do not have any kind of route response yet, but it will be populated automatically by the nodes. So now let's try to run it again. Let's see if we are able to get the response back from our agent. Okay. Perfect. I can just see the response, and I can see all of the data, and I can see the, you can say, payment methods that we have: Apple Pay, credit card, debit card, Google Pay, PayPal, and very good. Final answer is database stores 5 payment methods, and obviously the represented answer that we wanted to display. Very good. That means this agent is working fine. And why did you just see all of these things like in loop? Like this thing, quarks, this was like due to that particular thing. And this is not on my side, this is on the OpenAI side. Talk to Sam Altman, like what this model they have just created. So whenever you just perform any agentic behavior, I can even like stop this thing by literally creating, or you can say adding a comment here, instead of just providing here the model quarks. This is just because of that model quarks. Okay, cool. Simple. So nothing to worry. So if you also see this kind of loop, simply make sure that you have disabled this model quarks. And if you just disable it, then you will not be able to use it in your React agent. That's why I just use Claude agent, because I love Claude for building my React agents. And to be honest, Claude agents are better, bro, for coding. Better. I don't know why, but they are better. Okay, they understand, they just give you response better. I do not know about those benchmarks where they just compare the models, where they say, hey, GPT is better than Claude, but Claude models are like any day winner, okay, in terms of coding. That is for sure. Cool. So our data agent is working, like one part of data agent is working. Now I want to test the other part, which is my ETL agent. So again, I will simply go to my ETL analyst just to bring this particular human message. So let's say I just want to pass this information. Cool. Now we will simply pass this particular human message that we want to ingest the data, right? And let's see how does it behave. So let me just say clear, and let me just run this thing because my extract folder is empty. So if we get any file within this folder, that means it is working fine. If not, then yes, we need to just spend more few hours to debug the things. Oh, we got the data. Perfect. So extracted data.csv, and I can see the data and it is amazing. And obviously now I can just transform the data as well, but that is fine. So in short, my model is working absolutely fine. And do you know what? You can even just run all of the models directly from the main file as well, like directly from, let's say here in the main file, main.py, and you can simply import this data agent, okay, this data agent in the main file, and you can run this particular portion directly from there. Let me just show you how you can just do that. So if I just go to main file, because I obviously do not want to execute anything from within the data agent, this is just for the testing purpose, that's why I have added this thing, right? Cool. So now what I will do, I can literally perform this data agent thing here. So I can say from agents dot data agent, perfect, import data agent, cool. And here I can simply write the response that I have just wrote there. Let me just import this data agent. I would need human message just to send it as an argument. Perfect. So let's try to run this thing from here as well. If it works fine, then obviously it is working fine. Cool. And there's no harm in module not found ETL Analyst. Oh really? ETL Analyst? Where we are running ETL Analyst? Where is ETL Analyst? So no module named ETL Analyst. From ETL Analyst. Oh, from ETL Analyst import ETL Analyst. Makes sense. So what is happening right now here? When I just imported this thing directly within my, you can say, main.py. So obviously this particular thing will start looking at the things directly from here, like from within the same folder, and I do not have that thing. So what I can do instead, I can go to this data agent inside this, and here I can import this ETL Analyst and SQL Analyst directly from the root. Okay, so how we can just do that? It's very simple. From agents.etl analyst and from agents.SQL Analyst. Okay, let's see if it fixes this issue, because whenever we just make some changes in the imports, it breaks a lot of things. But be a debugger, okay? Be a debugger. Let's wait for it to perform our things. Let's wait. If it works fine, it should work fine, by the way. Yeah, I can see this thing. So yeah, so I can see that it has like successfully loaded all of the things, AI message, signature, everything. And just to test it, I can literally delete this particular data. Delete, and now let's try to run this thing for one more time, just for the testing purpose. So this looks now more clear, because here everything is like running from the main.py. And even if you just want to create, let's say, endpoint on this particular main.py, you can just create it easily. Or let's say you just want to run it from the root of the folder, you just need to run this main.py file like Python. Okay, it ran fine, cool. And I can, yeah, it works fine. And yeah, I was saying like you can even just run this file directly from the root, and you can simply say python main.py and it will work fine. And all of the imports within the independent file, let's say within this data agent, if you just go inside this, everything is being done at the root level. So you do not even need to worry about that, because within the same folder, it will just pull the package. Now, just a pro tip, if you are building any endpoints on top of these agents, you would not need to perform this particular append. Why? Because when you just run any application by default runs everything from the root of the project, basically working directory. So that way, when you just build the endpoints, you get some, you can say, flexibility there. But when you are just locally testing it, and when you're just doing everything locally, then obviously you would just need to use this thing. But when you are deploying these things to, let's say, VPS or any kind of web services, then obviously you can ignore this thing if you are using any kind of web application framework like Flask, Fast API, anything, because that way it does not require this thing. Even if it is there, it is not creating any kind of harm. But still, If you just want to ignore it, you can ignore it, because it works without this as well, only in the web frameworks. Because when your web app works, it works from the root of the project. Cool. Everything runs from the root of the project. Okay, very good. So congratulations, our data agent is completed, and I hope you have learned a lot of things. And now here's a quick homework for you. Now you can just try creating the similar agents in your organization, and yes, you can just take care of so many other things as well, which are like common sense, like adding some security guard rails, or let's say assigning the role, reader role, and blah blah blah, all of these things. And just try to create a data agent which is actually solving the business problems. Simple. Very well done. If you like the video, simply drop a lovely comment and share this video with others as well, so that they can also learn this skill which is in demand. Happy learning.